Hello. Okay. Hi. Welcome, everyone. Thank you for joining us. We are so excited for our second Software Engineering Tech Summit, the first of the year. My name is Isadora. I am the program manager at the European Leadership University, and I'll be hosting the summit today. So, the summit is organized by European Leadership University. ELU is a university offering flexible undergraduate and master's degrees programs in tech. And we are competency based and focused on portfolio building and mentoring by experts for our students to be job ready. So you can check the website to learn a little bit more about the programs and the offers. And I will also host an info session during the summit so I can explain how it works a little bit better. So, in the summit, we'll be talking about different career pathways in software engineering and how to get started in tech. We have many experts joining us today to share their wisdom and insights. So, we'll for sure learn a lot. We're excited to have 500 registrants from 20 plus countries. We would like to make this summit interactive. So, please share your comments, ideas on the chat screen. I'm curious to know where everyone is coming from, share your location, anything. So, and also if you want to ask questions to the speakers, you can use the comment sections and we'll try to answer it at the end of the live session. There will be 5 minutes break in our program between each speaker, but you can take a break anytime you like and join us again later. So let's go ahead and introduce our first guest speaker. Her name is Obiano Ju Okafor. Sorry if I said your name wrong. She's a computer science PhD graduate with a background in software engineering and works as a R&D software engineer at Microsoft. So welcome.
Hi, hello everyone. Thanks for the introduction, Isadora. I'm happy to be here. Okay, so I'm going to start with you know, some background information about myself and then how I went from no coding experience or no programming experience to getting a PhD in computer science. I would also talk about what I do currently at Microsoft, how I got there, and why, what are the advantages or benefits of being a software engineer. So I started this journey 10 years ago, a little over 10 years ago. When I applied to go to college, I actually applied to study medicine. So I wanted to be a medical doctor. But as you can see, that didn't happen. Well, I am a doctor, but I'm not a medical doctor. Um, so I applied to my undergraduate university, which was Eastern Mediterranean University, a university in Cyprus. I applied for the medical program, and then I was told that they don't directly admit people into the medical program, that you had to do a science program, like any, like maybe pharmacy or biology, chemistry. You have to do one of those for a year. And then after that year, if you performed well, that is, I think the threshold was if you got like a 4.0 or a 3.8 out of 4, then you would be advanced into the medical program. And then as at then, I mean, in high school, I was smart, but this was a completely new university. I wasn't sure if I was going to be able to deliver my first semester. So I was like, okay, I was admitted into the pharmacy program, and then I thought to myself, I'm not sure I am going to get that grade, and then if I don't get that grade, I'm going to be stuck in this pharmacy course for 4 years, which is not my um, initial goal. So then, right before the time to register for the semester, my first semester, I spoke with my dad, my father, and then I told him that, hey, I don't want to do pharmacy. I don't want to study pharmacy. Um, and that I don't know if I really even want to study medicine at the end of the day. And then he looked through my school's university catalog, that is Eastern Mediterranean University. He looked through that catalog and then he saw this course called software engineering. And then my two brothers, because I have two older brothers, they were both studying something similar. One of them was studying information and computer technology, and the other one was studying computer science. So my dad knew that this software engineering course was probably similar to those courses, and then he advised me to enroll in that course. And because that was the direction that the world was going in, because as you know, like tech is a very important aspect of the society today. So he advised me to study that course. So I took his advice. On the day of enrollment, I enrolled into the software engineering course. So that is how I initially found myself studying software engineering. And then when I joined my first semester, I didn't have any programming experience at all. So I struggled a little bit because remember, I was on a path to study medicine and not software engineering. So my first semester in the software engineering course, I struggled a bit because I didn't have any programming experience. And a lot of people in the course had programming experience from high school, but I had none. So it was a bit tough for me. I tried my best, but that semester I definitely could have done better. And then when I went home for the summer, because I started in spring, when I went home for the summer, I shadowed a software engineer for the summer, and then he was able to teach me a lot of the important programming concepts. It's really practical stuff like how to create a website, how to add pictures to a HTML page, how to create a form. So at the end of that summer, I was able to create a simple website with pictures of my favorite celebrities. I remember I had a picture of like Beyonce and my website, my webpage. So getting that hands-on experience, I became more interested in programming. Like I understood it because I had practical experience. So the next semester, when I went back, I didn't struggle as much. Actually, I became better. I became better than I was before. And then because I was better, I was also practicing more because I had more interest in it. And the more I practice, the better I became. So like coursework, assignments, exams, they became much easier for me than it was the previous semester. So that was how it happened. Each semester I kept on getting better, better, better. And then by my last semester, I actually graduated the best in my class. So my university gives an award to the person that graduates with the highest cumulative grade points average. And then I was the best in my class in the software engineering department. And then I got an award. So that was a very proud moment for me because I had started not even knowing I wanted to study software engineering. I wanted to study medicine, and then I happened to find myself in this software engineering course. It was a bit tough for me at first, but then I kept on going. I could have quit. I thought about quitting a lot of times, but no, I decided to keep going, and I am so glad that I did because I wouldn't be where I am today if I had quit my first semester after finding programming really hard. So yeah, so I graduated best in my class. And after graduating from my undergraduate degree in software engineering, I wanted to further my degree. I wanted to get a master's. But this time around, I wanted to expand my knowledge. I didn't want to just get a master's in software engineering again. I wanted to get a master's in computer science because I felt like computer science was broader, and I wanted to diversify my skill sets from application development, web application development, to other aspects of computer science like cybersecurity, machine learning, artificial intelligence, algorithms. So I decided to apply for. I applied to multiple schools. I applied to schools in Europe. I applied to some schools in the UK. I applied to schools in America as well. And then I had an offer from I had an offer from the university I graduated from, for a master's in computer science. So I was accepted into the master's program in computer science at the University of North Texas. It is a school in Denton, Texas, which is Denton is a city in the Dallas Fort Worth area. So I was accepted into that program, and then a professor reached out to me, which ended up being my supervisor. She reached out to me and she said that your cumulative grade point average from your undergraduate degree is very good. Also, your GRE. So GRE is a graduate exam, so it's an exam you take to go into graduate school. So she said that my CGPA, which is my cumulative grade point average, was very good, and my GRE test scores were very good. And she asked me if I wanted to switch from the master's program, which I was accepted, into a PhD program in computer science. And then as an incentive, obviously, as an incentive, I was told that the program would be funded, so I wouldn't have to pay out of pocket. I had I had planned on getting a PhD, but I wanted to start with a master's first. But when this opportunity presented itself, I decided to take it because, hey, I was always going to get a PhD eventually. So why not do it all at once? So that was how I went from an undergraduate degree in software engineering to getting admitted into the master's program in computer science at the University of North Texas. And then changing that into getting a PhD in computer science at the University of North Texas. So in May of last year, I graduated with my PhD after 4.5 years. The entire program was pretty great. I learned a lot of concepts that I didn't know before. Like I had a lot of machine learning. I took machine learning courses, artificial intelligence courses, programming languages courses, analysis of algorithms, data mining, cybersecurity. So I was able to take a lot of different courses that were different from the ones that I took in my undergraduate degree. I was also able to perform several internships. I did an internship at a research scientist internship at IBM. I did UX research and development internship at Salesforce. I did a software engineering internship at Macy's. So while in the PhD program, I was also able to get hands-on experience by with these internships. And by the end of my PhD program, after graduating, I received an offer from Microsoft, a software engineering position on a research and development team, and that is what I am currently working on right now. Before I go into more details about what I actually do at Microsoft, does anyone have any question for me? Any questions before I go into more details? Not yet. Okay, great. So, yeah, so like I said, I graduated with my PhD in computer science from the University of North Texas in May of 2022. I received an offer from Microsoft, a software engineering position on a research and development team. And then I started at the end of August of 2022. So I've been at Microsoft almost 6 months now. I work on the data SQL team. Um, and in that team, we work on Power BI. Power BI is a data analytics application. I'm not sure if you're familiar with it, but it's an application where you can visualize your data. You can store, you can interact with different data sources and then visualize your results and use that to analyze the data. And then I'm also working on some another application called Data Mart. Data Mart is a way to store your data and then use it in Power BI. And then I am working on a variation of Power BI that hasn't been released to the public yet, so I can talk about it. So yeah, that is what I currently do at Microsoft. I also collaborate with research teams at Microsoft, working on making applications more accessible, um, And then what else do I do on a day-to-day basis? I would say I have at Microsoft. I would say I start the day checking my emails. After checking my emails, I usually have a meeting in the morning, and then after my meeting, then I after my group stand-up meeting, then I start whatever task that I have, either look at a bug or work on a feature. And then yeah, and then we have sometimes we have talks that have been organized, which we attend. And some other times I do one-on-ones with other people at Microsoft just to get to know them and what they're working on. Now, which brings me to the next part, which is why you should be a software engineer. I think there are many different reasons why you should be a software engineer. The first one is it's profitable. I mean, especially in this economy, it's very remunerative. So you get paid pretty well as a software engineer, regardless of what company you are at. You get paid well. Another thing is you're at the forefront of technology. So you're always working on something that is next level, cutting edge, which is very interesting. You get to work on very innovative technologies and applications. And that is very interesting. And then seeing your applications get used on a day-to-day basis, so actually looking at the impact of your work, it's also very fulfilling. So there's a lot of fulfillment. You're paid decently well. You're working on cutting edge technology, which is very interesting. So you're always motivated. Also, it's fulfilling because you can directly see the impact of your work. You can see people using your applications. I remember in my PhD program, I worked on a programming application that allows people with um, visual impairments and people with motor impairments. It allowed them to write program, and then seeing the effect of this. So we conducted tests on this application with our participants, and seeing the direct impact of this was very fulfilling. You're also helping society. Like the world revolves around technology. This application that we're using right now. Was created by a software engineer. Google was created by a software engineer. Zoom, Facebook, a lot of things. Everything requires technology. Your TVs, the apps, Netflix, Hulu, your fridge, your thermostat. Like a lot of things require technology. So I'd say that you're at the forefront of technology. You're helping the society, you're impacting the lives of people on a day-to-day basis, and also you're getting paid well. So I'll say that those are some reasons for becoming a software engineer. And then I'd like to ask if anyone has a question. Does anyone have a question for me? Oh, great. That's a nice question. What is the difference between software engineering and computer science? So yeah, I would say that first of all, software engineering is more um concentrated. So software engineering is a branch of computer science that deals with developing web applications. So computer science is like a broader, it's like a broader term. It has more aspects. So computer science deals with theories, and how to solve problems, basically using theories or like using algorithms. While software engineering is a subcategory of computer science that deals with creating web applications or creating technology, developing technologies. But computer science also relates with other concepts, not just web application development or mobile application development. You also have machine learning. Machine learning falls under computer science. Artificial intelligence falls under computer science. Data mining falls under computer science. Cybersecurity falls under computer science. Memory, a lot of different concepts. So computer science just relates to the it relates to how you can use technology to solve And by technology, I mean like obviously the use of computers to solve a lot of problems. While software engineering is more niche and is more concentrated and it relates more to application development. And which was one of the reasons why I wanted to diversify my skills by getting a graduate degree in computer science, because I wanted to get hands-on experience on different aspects of computer science and not just web application development and or application development as a whole, not just web. And then this also served me well because I was able to get like different internship. I know I did um at IBM, I worked on the machine learning team as a research scientist. I conducted research there. Also at Salesforce, I also worked on a machine learning team. I did user experience research. So that is user UX research. I did UX research there. At Macy's, I also worked on a machine learning team. So I would say diversifying my skill set has allowed me to work at different roles at different companies. So that is an advantage of computer science, is that you get a a broader knowledge about different concepts and not just one. As a software engineer, what can you say about the environment at work, Microsoft, IBM? Do you feel overwhelmed with tasks assigned to you, and how do you get to free yourself from burnout? That's a good question. I'll say the working environment at those two companies are very good. I really enjoyed my time at IBM, and I'm currently enjoying my time at Microsoft. As a software engineer, so I wasn't a software engineer at IBM. I was a research scientist intern. So my day to day was a bit different from what it is at Microsoft, but they're pretty similar. Um, Also, the working environment is great. Everyone is really smart and everyone is working on really important things. And everyone is always willing to help, which is a big thing, which is one of the things I really like about these two companies, is that everyone is always willing to help. So even when you feel overwhelmed, because when you join a company, certainly companies like Microsoft and IBM that have existed for years, I think they existed even before I was born. So joining companies like that, when you join, it can get overwhelming because there's a lot of things you have to onboard. You have to catch up with the technology. You have to learn what technologies that you're using, the programming languages. So it can be overwhelming at first, but I'll say that like what my manager or the people on my team tell me is that everyone goes through it. They don't expect you to join the team and start excelling immediately, because everyone, at least for like 3 to 6 months, you're just learning, right? And they're pretty understanding about that. Almost every company is pretty understanding about that, that when a person joins a team, they're not going to start performing tasks or being 100% productive the first time they join. They need to learn the technology, they need to learn the environment, they need to interact with their coworkers. So I'll say like you feel overwhelmed, but it's expected to feel overwhelmed. No one expects you to join and become an expert on your day one. There's a lot of grace that is going to be given to you to learn, and then eventually or gradually become productive. So that is fine. You're going to feel overwhelmed, but it's expected. Everyone goes through it. So just be patient with yourself. That is what I would say. And then how do you free yourself from burnout? I'll say um creating a good work life balance is how I try to avoid burnouts. And by that I mean, right now I'm working from home, so it's pretty easy to have a blurred line between your work and your life. So what I'll say is I as much as possible, I try to delineate the two. So I have a fixed time for work and then a fixed time for myself, and then after that fixed time that I have for work, then I handle my other task or things, personal stuff that I have to do. And I'll say that's one thing I've done to avoid burnout, is to be very specific or to draw a clear line between work stuff and personal stuff, and making sure that I make time for both and that I'm not sacrificing. Obviously, it's gonna be hard to, like, especially working from home. It's kind of hard to, like, separate the two, but I try as much as possible to separate the two. Make sure that I'm giving myself enough time. I'm taking my breaks, because you have a break. You work an 8-hour shift, and then you usually have a break. Making sure that I take my break, making sure that I also do other things within the company. Like, at Microsoft, I'm part of an organization called BAM, which is Blacks at Microsoft, and they also do events. They do events. Apart from Blacks at Microsoft, I'm also part of some mentorship circles. So in those mentorship circles, you interact with other people at Microsoft. You talk about your experience with them. They give you advice. You can ask for advice. You can also get assigned to a mentor, so where you meet with them one on one. So I would say not just focusing on work, but making sure that I'm also interacting with other people at Microsoft, sharing my experience, listening to their own experience, and just involving myself with other aspects of work that is not just performing my task. That is another way that I don't get overwhelmed, because or burnt out, because if I'm just working 8 hours a day, and I'm not 7 days 5 days a week, and I'm not interacting with other people at Microsoft, I'm not attending events, I'm not attending this communities, or I don't have these communities, or I'm not part of this mentorship circle, I can get burnt out easily. So, like, involving myself with other organizations within Microsoft that don't necessarily have to do with my job role, making sure that I separate my personal stuff from my work stuff, and giving each of them the time that they need. I'm also, I would say that another way that I don't burn myself out is also having other interests outside of work. I like to travel, so I try to travel as often as I can, like at least once or twice, or 3 times a year. I try to travel, take a vacation for myself. I also like fashion, so I like to, like, shop, dress up and things like that. So yeah, those are some other things that I do not to burn myself out. Is I have other interests outside of work that I can use to let's say reset myself, so that next time when it's time for work, I can fully pay attention. So another question is, how does one transition from a biological postgraduate in bioinformatics and computational biology to an MSc in data science or computer science? Um, hmm. Let's see. I'm gonna try to answer it as much as I can, but bear in mind my background is software engineering and computer science. So I can only say what I would think you can do, not what you can do, because I haven't gone through that path yet. So I would say a good way is, I think there's a master's course called um MIS, Management Information System. I know that that course is not core computer science. Like, there are other courses that you take. There are other courses that you take within that program that you can take data science. You can take some other business courses as well. It's not heavily focused on computer science. So what I would say is going for courses like that are not heavily that are not very technical, because what I would say, going through the computer science program, is it's very technical. So if you didn't have a computer science background at all, in your undergraduate degree, you might struggle. It is not unheard of. You can do it, but it's gonna be tough to go from it's gonna be a bit tough to transition from a biological postgraduate. Wait, let's see, computational biology. It might not be that hard. Actually, thinking about it, if you have programming experience, so what I would say is, if you have programming experience, switching to a MSc in data science is not going to be tough, because if you have programming experience, you can easily pick up Python. That is, if you don't already do Python. Um, if you don't already program in Python, you can pick up Python pretty easily, and that can help you switch into the data science route. Now, going the computer science route, it's gonna be tougher. You just have to do a lot of work because you have a lot of years to catch up on, and going into a PhD program in computer science or a master's program in computer science, it helped me a lot that I had an undergraduate degree in software engineering, because a lot of the concepts were similar. But I can see if I didn't have that undergraduate degree in software engineering, I might have struggled. So my advice would be going more in the data science route, picking up Python, learning how to work with notebooks. Um, um, there's a Jupyter notebook. There's a collaboratory notebook by Google. Pick up Python or R. Also see how you can apply Python or R to a lot of the computational biology problems, because right now, sorry, I'm gonna wrap it up, but right now in healthcare, technology is very important. So I'll say finding a way to blend the two together and not just going from one to the other would also be advantageous. I know that companies like Pfizer, Johnson and Johnson, they hire a lot of people like data scientists, right, that have knowledge in computational biology, and then you can use that knowledge of data science to solve a lot of problems in the healthcare field. So I'll say pick up Python. That is number one. Learn Python if you can. Learn how to use notebooks, learn how to feed data into the notebook and use Python to analyze that data and visualize the data. And yeah, you should be fine. It shouldn't be so hard to jump from a computational biology background to data science. I know there are a lot of programs that you can do that with going from computational biology to computer science is going to be a little bit tougher, because computer science is very technical, and it's very like it has a lot of maths. That's another thing. So if you don't like maths, it's going to be harder for you. But with data science, you don't have it's not as technical as computer science. So I would say going more in the data science route, and a lot of programs allow for people to go from computational biology to data science, because a lot of companies these days, a lot of health or biotech companies these days, they use data scientists. So yeah, that would be the route I would go in.
Thank you so much for sharing everything with us. It was a
Yeah,
pleasure
thank
listening to
you.
everything you had to say. Um, so now, for the next session is me, so I can introduce myself. Just kidding, but it's actually me. I'm going to be hosting an info session to talk a little bit more in depth about the ELU and its learning program. So, like I said before, I am the program manager at ELU, and I'll be hosting the info session today. So, thank you for joining. Um, can I put my slide up? Okay, so what to expect from this info session? We'll be sharing the mission of ELU, why we were founded, our philosophy. Then we're going to talk a little bit about the ELU learning experience, which is a little bit, it's different from traditional universities, and an overview of the curriculum of the 3 bachelors that we offer, and then information about application, admissions, and tuitions. So ELU is wait. ELU is a young university. It was founded a few years ago. It's focused on tech and IT domain. So it was founded in response to the tech skills gap there is in the Netherlands, but also in the rest of the European Union. So a lot of companies are looking for tech talent, but not enough of this talent is trained academically with the skills they require on the workforce. So we see a higher need for tech professionals, a skills mismatch or knowledge that you will be learning from a traditional university versus the skills that employers are looking for. So this leads to a need for a different educational offer, which is the mission that ELU is serving. Um, we are focusing on developing job ready tech talent. So when you graduate, you should have the tech and leadership skills that you need as a tech professional. It's not only focused on the technical skills, but the 2 first years are mainly focused on these tech skills, as you will see later on. We are also focused on the business skills, so how you actually communicate your product to a sales team or a stakeholder, for example. So this is very important as well. So our educational model key highlights competency-based learning. So our programs are designed around skills that have been identified in conversation with people in the market, technical skills and interpersonal skills you'll need as a professional. It's project-based learning, so it's practical learning, weekly-based projects, individuals or in teams. We also have an employability focus. This will help you with your portfolio to include it as you're applying for internships, for jobs. There's also facilitators and mentors that are working in the industry, so you can hear what it looks like to work in the field. And then there's also a peer-to-peer focus. Since it's an online university, it's very flexible, and you have that aspect of self-study. But you also have a cohort with students and groups that help you with projects and a community to engage with. So the programs that we currently offer are 3 bachelor programs: the software engineering, AI and machine learning, data science, and we also offer a master's program in data science. So for the last question that someone asked, you can do the master programs in data science, but I'm going to focus on the bachelor programs today. So the target competencies that we have for the programs, it's a 3-year structure. The first year is we have the technical and non-technical competencies. We have for software engineering, for AI and ML, and for data science. They have different technical competencies, but the non-technical competencies are the same. So the leadership skills that you're going to be learning are the same for the 3 programs. So I will focus on the program structure now. It's a 3-year program. The first year is basics, software programming for all of them. The second year is more of a specialization, and the third year is business skills, agile working, but also consultancy skills, working with clients, pitching to clients, and then you have a final graduation project where you put everything you learned in the 3 years into practice. So you can see here the details of the modules of the different programs that we have. You see that year 2 have more technical projects as well. So I'm going to explain how the learning experience and how everything works on a weekly basis. So at the start of the week, you log into the course platform and you can see your material or your content for the week and your project. So there's a digital library there. And then you can get started with your project. And then you have a workshop, which is an hour and a half to 2 hours with your facilitator and the rest of the people in your cohort. There are different facilitators for different modules, which are people that are actually working in the field of data science, of software engineering. And then you have the squad meetings, which is meetings that you're going to have with your peers to talk about anything that you think is important that you want to share with, help with projects, anything like that. Then we have the stand-up meetings, which is 2 times a week with all of the cohorts. People can talk about problems they're having, what they're going to do that day. It's a chance for everyone to get together and talk a little bit about what they're working on. And then at the end, you're also going to be working on your project, where you have the group mentoring, where you can ask specific questions about the programs. and you also get more support for the program content. Um, so we use some platforms. Important platform that we use is Campus, which is the course platform, which everything is consolidated into this one space. Your calendar for webinar, workshops, events, for the stand-ups, for the mentoring, everything is going to be on Campus. Your assignments will also be there. There are discussions with other students. Your grades will be there. So it's also important to log into Campus all the time. You're going to see when your due dates are. You're going to have all of that information in one place, which will be Campus. And then we also use Slack, which is an instant communication platform. We make real-time announcements and updates. You can talk and form groups with different students as well, and contact the faculty and the university staff. And Slack is very nice to engage with the community. So if you're having a problem, maybe you don't want to wait until your mentoring session. So you go to Slack, you ask a friend of yours in the cohort appear to help you with something. So it's nice to have that instant communication since it's an online university. It's good to have that available for us. And then a little bit about admissions. The academic background that we'd like to have an English proficiency, EIELTS 6.5 or higher, and the TOEFL 234 or 90 to 91. And then for a professional background, it would be nice to have a work experience in the field, but it's not 100% necessary. You can also not know about programming and learn during the course. The start dates are March and September, and we accept applications on a rolling basis. So if you want to start in March, you can still apply. And there is no application fee, so you can still apply for March and get into the March cohort and already start your career in software engineering. And the application process that we have is you fill the online application on our website, you submit your CV and your motivation to start the program. Then you complete a video interview, which it can be done fast, and then you receive your application results, and then you're in. And then for the tuition, the registration fee is 250 euros. Total fee for the bachelor's is 2,900 euros a year, so that is times 3. And you have payment options. You can pay yearly, you can pay biannually, and you also can pay quarterly. So if you're aspiring to become a software engineer, an AI ML engineer, or a data scientist, this would be a nice program for you. If anyone has any questions, I'm free to reply to them now. And you also can reach us at these 2 emails if you want more questions, if you don't know what to ask right now. If you register yourself, can you pay installments like 300 or 500 a month? So like I said before, there's the payment options. So there's the quarterly options, which is 4 times a year you pay 800 euros. So that monthly would be 200 euros. So I think that kind of answers your question, that yes, you can pay in installments. Is there any other question about the program or anything else that anyone wants to ask? Oh, and to apply, you can go on our website as well, and also send an email whenever you guys want. So this was a little bit to talk about ELU, to show everyone how it works. But next, I'm going to introduce our next speaker, which is Victor Lucas. Victor is the software engineer at Evonitex and is also a facilitator at ELU for our bachelor program. So he understands a lot about the program. And he's going to be talking about the differences between the skill-based learning and versus traditional university. So welcome.
Thank you, Isadora. Hi everyone. Yeah, first of all, I want to speak a bit about myself, give you a bit of background about who I am, what I did to enter the field, because it's not something that I don't have like a regular um, parkour in in software engineering, because I started working when I was 21, and so to do that, basically to go very fast, my goal was to get employed as fast as possible, because what I was believing and what I still believe is that the best way to learn and to progress in your career is to get employed. When you get employed, you get real life problems. You start to you have the staff, you have the monetary constraint. What I saw a lot is people trying to get the degree, basically, and that was not my goal. My goal was to get employed, and basically I took several steps to go there very fast. Sorry. So first of all, I've been helped by the fact that I hated high school a lot. Like I despised the traditional system. It's not made for me at all. And so what I did is I dropped out of high school at 17, so just before graduation, and I didn't get any diploma from that. So I had a plan. Obviously, I didn't do it just to do it, but I joined some course which is French, but it's kind of remote now, which is called 42. So 42 is a project-based course that is lasting as long as you need, basically, and so I said project-based. It's also based on peer learning, meaning that you are learning not with teachers, but with other people, with your peers, other people following the same course as you. So you build projects together, and then you get graded by other students and by the machine itself, so by algorithms. So 42 was a great option for me, but I discovered some discrepancies in the programs that I think we are addressing right now at ELU. So yeah, I don't know, Isadora told you, but I am teaching at ELU as a facilitator, and I'm also employed at Evonetics, which is a company based in Cambridge that is synthesizing DNA using robotics. Um, so as I was saying, so 42 has discrepancies, but not as much as the traditional university. So first, what I want to do is to give you an overview of what's the differences that are going to be between a traditional university and a university like ELU and 42, which is project based, based on peer learning and everything. So first of all, when you're going into a traditional university, what you're going to get is a lot of stuff. You're not going to get specific stuff for you to get employed, right? You're going to get a bit of this, a bit of that. Some people on biology when they are doing computer science. It's not or electrical stuff. And this can be very interesting. I agree with that. It can be very fulfilling to learn a lot of stuff, but that's not really what you're going to need to enter the industry, right? Because when the CEO employs someone, he wants it for a specific job most of the time, and unless you're like in other cases, but we are talking in general. So general traditional university are going to focus on a lot of stuff, while project-based university are going to give you the exact skill you need to enter a specific industry. So that was the difference. The main difference is this, and it's relying heavily on classroom-based learning. And I have a big problem with classroom-based learning, which is that you are staying passive in front in the classroom and doing basically nothing. I mean, you're not active, is what I mean. When you are in a skill-based university, you are going to build all the time. You are going to be on your computer, writing code, testing code, developing code, and you're going to talk to your peers about problems, and you're going to have to fail before you succeed, which is a contrary of which is exactly, sorry, what's happening in the industry, and the contrary of what's happening in traditional university, where the teacher is going to give you the solution and then is going to evaluate you on what you know. So you won't have this process of learning to solve problem. So that's basically what it is. When it's project based, you're learning to solve new things, new problem, and so that's extremely important. 60% of a software engineer job is to find information and solve problems. Then you have the skills, right? You have, am I able to develop the solution? But that comes after, like actually understanding the problem and solving it, right? And finding a high-level way to solve it. So that is the two main difference between skill-based and the traditional university. And at 42, so I told you I dropped out of high school when I was 17. I tried to join 42. So the process for 42 is quite complicated to get in. And as I said, it's not the best thing we have now, but it was the best thing back then. So I failed basically the first time I tried to get in, and then I succeeded and entered the course. One of the other things that I found very useful for my career, to start early and get as much experience as possible quickly, is that I stopped learning in French. Okay, so I'm French, right? Yeah, I mean, I guess you can tell my English is not perfect, but it is good enough to work. That's what I wanted, and that's why a lot of people don't really get all the opportunities that they can, is because they are in a country like Italy, Spain, and they don't really try to learn in English, to learn the main language, right? The global language, because you need to live with the world. The world is global. If you want to catch all the opportunities, you want to work remotely, then you need to know English. You need to learn in English. And that's something I understood after like 1 year at 42. And what I did is move directly to the US, where I started learning the language as soon as I could. But that's because that was my only way to learn in English, right? Now we have universities that are remote and that teach in English. And that's great to also develop your skills in that language, learn the industry lingo, all this stuff. So that's primordial for me. And I really think everybody should do it, because you will still know Spanish, you will still know French, but you have this skill, and you're getting this skill passively. You don't have to do anything to actively, like, you don't have to go to an English school. You just have to be in a school that teach in English. So that's something I would recommend, and that's something that is overlooked by a lot of people. This is, in terms of value, this is insane. Learning a new language by learning other things, you don't. It's really, really, really important. All right. So that was the two main difference between traditional university and the new kind of university, like ELU, like 42, project-based, peer learning. And also, I want to also talk about the fact that traditional university, since you're passive, meaning you are getting information, you are not going out there to take it, you are not doing a project, you are getting information for a test, for a diploma or whatnot, then it doesn't it doesn't make you go do the next step, like work more than you can. You just get the pace, because the pace is the pace. That's how it is. So it doesn't make you go further. It doesn't. You don't have this this feeling. Oh, I'm going to do this next project because I finished this one, right? I finished it early. I worked a lot. I can go to the next one. So when you have this possibility, you're going to work way more, because you're gonna be like, okay, I can finish this program in such a short time. So why not do that? I will gain experience very quickly. I will get on the market quicker. It will be best for me. Or rather than when you are in a traditional university, they're going to make you learn some stuff you don't really need, and it's going to be is going to be on a determined time frame, right? Why it's kind of like that as well at 42 and ELU, but it's not exactly the same. You still have this drive to do the next thing, right? So that's very important as well. So yeah, and so now I'm going to talk a bit about why peer learning is so important. So yeah, peer learning is basically working with a peer and working with other people that know not too much and not too little, basically people at your level. That's why we call them peers. So if you are learning from a teacher, the thing that's going to happen is you're going to get a skill without being able to search and to learn by yourself. Learning by yourself is possible now. Learning by yourself is, as long as you have a nice framing, learning by yourself is best. Because if you learn from a teacher, first of all, the teacher is only one source of information. So internet, you can choose from any source of information what's the best for you, what is the material that will stick in your head, because that's not the same for everybody. Everybody's different. So something that might work for me might not work for you. So you want to be able to find what works for you. It's going to give you high confidence to do stuff by yourself. And that's crazy in terms of mindset, because you will never be in front of a problem and tell, oh, I don't know how to do it. You'll be like, yeah, but that's the same for every problem. Each time I'm in front of a problem, I don't know how to solve it. But by working, by searching by myself, by using different resources I find online, I can solve it. And so it gives you a lot of confidence. And also it doesn't make you reliant on on someone who knows best, on the teacher, because the teacher won't be there on your interviews. The teacher won't be there when you're on the job. So you need to be able to be efficient by yourself. That's a skill that is very valuable for people that are hiring you. Nowadays, the diploma is important because it's especially if you come from a university where people succeed, because it give you a label, but it's not enough. That's not the only thing that people look for. What people look for is people that are able to solve problems and their problem, right? If I'm hiring someone, I want him to be able to do what I need him to do. I don't care if he does have 5 diplomas or 0. That's how I got hired. I got hired because I got a portfolio that was huge, because I was doing a project-based university. And by doing project-based, you have 10 projects to showcase to the employer, and that's how you get hired. The guys were like, oh, so you made this project that's super interesting, can you talk a bit about it? Well, if you have just a diploma, he's not gonna talk about your diploma for hours, because maybe it's not even especially relevant to the industry itself. So it's really it's really for now, like in today's age, it's impossible for me to be like, I'm going to go and do something for a degree. I'm going to find the education online, do a project about it, showcase that I have the skills to get employed, and then use persuasion to get in. That's the easiest path and the fastest and the most rewarding, because you learn a lot. You learn a lot more than when you are here passively getting lectured by someone. So that was mostly what I wanted to talk about for in terms of macro, let's say, teaching. I want to talk a bit about. We have a question. Can you put again the question? ELU program meant for those who don't have an education background in CS or similar courses. Exactly. So at ELU, so that's why 42 has discrepancies. 42, you get in. If you're not good enough, goodbye. It's quite harsh. At TLU, we did a system where we still want the best of the world of project-based, of the world of peer learning, where people are going to solve problems together, get skills together. and but we still want to help you if you have trouble, right? So we that's why we have workshops, we have mentoring, we have stand-ups, we have all this framing, all these calls that are giving you a healthy environment for you to thrive, even though you're not an expert when you join. That's why it's not like a diploma printing machine. We're not selling a diploma printing machine. We're selling a block of skill that will make you a dope engineer in a very short amount of time, because we are focusing on the main things. So to do that, like the curriculum is in software engineering, at least, is centered about C, because then you understand everything on the micro level. You understand what everything does, what are the components, what they are doing together, how it works. And so when you have that, you are able to build, like, you need the bricks to create a house. And that's exactly what it is. C, you're gonna learn everything about programming, and then when you're gonna go to Python, you're gonna learn that in 2 weeks. You're gonna be like, okay, I understand the logics of everything, and I'm able to do it by myself. So even if C is not widely used, I mean, C is still widely used, but it's not. I'm talking about the C language. If you don't know about it, it's just the main language, like one of the first language ever created, where most of the language are based upon it. And we are teaching this core language because people, when they know this language, they are able to expand in terms of like, they understand everything that they are doing. Rather than if you start with Python, then you might do stuff without understanding how it works, or memory management work, and so it's not really the best. So yeah, it's meant for people without CS experience. And I'm not saying it's going to be easy. That's not what I'm trying to say. But it will definitely, if you work hard, you have the structure. We did put in place the right environment for you to thrive. Would you say that learning from a teacher plus learning further by yourself would be better? So today, as I said, most of the knowledge is available online. The problem is that doing everything yourself is extremely difficult if you don't know where to start, and you don't know which projects to do. You don't have the bricks. You might not have a network of people that knows already the language you're trying to learn. So it can be very complicated to go out there, take an ID. You will take the wrong ID. You won't be able to run anything, and then you will be discouraged, and you won't be able to do this regularly on a long time frame. The secret is to do that on a long time frame. If I do that for 2 months, like the other bootcamps are selling, like, you won't be good. You won't be good. You can't be good in 2 months. That's why you need to you need framing. You need people around you to do the things. You need a good curriculum to follow, and you need teachers. I mean, you need mentors. It's not really teachers, it's facilitators, mentors, people around you, that when you are stuck for too long, we won't let you get stuck for too long, because that's not what we want. But at ELU, you're going to fail. You're going to fail, and then you're going to succeed. You're going to succeed, and that's the best way for you to learn. If you never fail, you can't solve problems, because at the first difficulty, you will be like, I don't know how to solve that. I can't do it. And that's something we want to avoid. So that's what I think is important about ELU. So yeah, if you're interested and want to, Isadora asked me to talk about some things as well. So yeah. So what are the top skills? So yeah, Isadora asked me to answer this question. What are the top skills a software engineer should have today? So as I said, ability to solve issues. Sorry, I have a lot of sun. I won't complain about it, but right now it's a bit annoying. So being able to solve issues and to work as a team. And this is what's best about peer learning, is you learn very early how to work on a team, on a project that is scalable, how to build a project, which is basically what you're going to do in the industry. and also, of course, problem solving. So working as a team, problem solving. What else? Learning by yourself, being reliant on yourself, trusting yourself. Important to have a strong knowledge in math? Not really, especially for software engineering. It's not very. You can get very good jobs without it. I would like to learn AI ML in the future. Most of the people at Google, and if you want to get at Google, at the top companies in tech, you don't have to know math. You just have to be very good at solving lead codes and have a good portfolio. That's how the interview process is. Sorry, you have like it's first a lead code. So you have to you can look it up online, but it's basically an algorithm problem about the design pattern, and you have to solve it with the very good time and space complexity. And then you have system design and all these things. So we do that at TLU, and we also do interview preparation, everything that is optimal for you to get a job as fast as possible, while giving you all the tools you need to be a great engineer. And if you want to learn AI and ML in the future, we already have a bachelor completely dedicated to it, which starts with Python directly, not C. You have still a bit of C, and then you're going to do project about machine learning and AI. You have to choose one of the two paths, I think. No, sorry, it's data science. It's either data science or AI ML. So you have to choose after the first year, and then you will be able to find a job in that field. All right, I think that's all for me. Do you have any more questions?
I was in mute. Hi, Victor. Thank you so much.
I got the sun.
That's good. We can't complain about the sun.
Yeah, true.
Thank you so much for coming and talking a little bit about the differences in the two universities, and for taking your time.
Thanks, Isadora. Thanks, everyone.
Bye.
You can find me on LinkedIn if you need. I think you have the link. Bye-bye. Bye, guys.
Yes. So next up, I'm happy to introduce Leandro Lages. He is the Director of Software Engineering at Delivery Hero in Berlin. Leandro will be telling us some hidden skills that every software engineer should have. So welcome. I'm glad you could join us.
Thanks, Isadora. It's a pleasure for me, and I'm very happy to be here, right? I prepared a small presentation to guide through the next 20 minutes. And basically, what I'd like to talk about today is the hidden skills that every software engineer should have. And basically, it's not about the hard skills. I believe the hard skills actually, it's a no-brainer. We all should have, but at the same time, is not the only thing that we should have, right? So basically, who am I? I've been working in the industry for more than 20 years. I'm originally from the north of Brazil, a city called Belém. I've been living in Berlin for the last 7 years, working at Delivery Hero for the last 3 years. Exactly today, I'm making like 3 years Delivery Hero, so very, very happy to be here. And I've been working as a director of software engineering, leading 5 teams with 25 plus engineers in my group. And what is my motivation today to talk about those hidden skills? It's basically my own career growth, and in combination, also the last 5 years, I believe our industry changed a lot in terms of expectations for the software engineers itself. And basically, in the last 5 years in Delivery Hero, I actually had a growth in my career. And I wish that I knew a little bit more about those hidden skills before. As you see, like I had a steady growth over 15 years, and I I believe that I navigated this wave of the transformations that happened the last 5 years and helped me to shape my career, right? So, and I think the change to a more leadership position, people management position, the fact that I was involved in hiring processes, in defining what are the roles, what are the expectations that are now needed for engineers, helped me to actually navigate and create those basically hidden skills, right? You know that our industry changed a lot. Engineer management, staff engineer, we have so many now roles that are well defined. I believe the access of capital also created a lot of startups in the last 5 years, generating a lot of positions to the tech industry. So there was a need to actually define what are the engineer career growth looks like, right? And basically, today also if content became a commodity, we basically have a lot of newsletters around, a lot of topics about leadership or how individual contributors should behave in their career. And one of the motivations that I saw while hiring people, while forming teams, is that our industry is not moving in the same level in terms of career growth. The engineers itself, they are lacking of those skills. And I believe those skills, while they are not needed because the engineers with the hard skills, they can still have a steady growth. If the engineers want to actually potentialize and like amplify their career growth, I believe they should have, right? And basically this is basically the agenda. I'd like to talk about 4 skills. One of them is introspection, decision-making, collaboration, and resilience. Those 4 skills, I'd like to talk individually from each one of them. And basically, let's start with retrospection, right? And for each one of the skills, I'd like to tell what they are, why they are important, and where to apply on your career. And basically, what is retrospection? Without retrospection, you cannot self-reflect, right? The fact that you can self-reflect, and you shouldn't self-reflect every year or every 6 months, you should every day be this self-reflection, or what your career want to be, what are the weakest points that you have, what are your blind spots, what are the points that you need to actually improve, and will help you to create also the ability to find missing opportunities, right? Sometimes without this retrospection, you can just jump into a career, take a task, execute, take a task and execute, but you actually don't grow your career so much, right? Because you're not constant self-reflection. And why this is important? Because it's going to speed up the feedback loop about what are the things that maybe are missing in your career. It's going to enable a growth mindset. This is also something that I believe engineers should have, right? So where are my points where I should grow? I should never be satisfied from the things that I know today, mainly because our industry is so much complex, right? It's quite impossible over the life of your career to actually know everything, right? So also all the companies, they have different business needs, and every business, the same things that you learned might not apply in the other one, right? And also it's important because it creates a habit of motion on yourself over passiveness, which means you're not on a passive approach. You actually need to move yourself to actually find those opportunities and so on. And this retrospection on an individual level is very important. And where you can apply, of course, to define a clear career growth for yourself, instead of just let it go, right? And let's see where I go. It's going to help you to define where I want to be like in 1 year or 2 years from now, right? So what are my possibilities? Not necessarily need to define where you go, but basically what are your possibilities, right? And you learn on the way where you pave your path. Basically, it's going to help on your performance reviews, right? I believe one of the changes in our industry today is basically most of the companies are creating performance reviews, and basically that's a way to actually create awareness and growth between everyone. Yeah, it's going to help set clear expectations for yourself when you work in a company. And last but not least, will help you a lot on interview processes. One observation from my side is a lot of people, they don't retrospect about like the hidden skills or the soft skills that they need. Usually they think that they know the technical part because they did A, B, and C, but sometimes it's not about the hard skills, it's about the soft skills that you have, right? And the fact that you are aware, that you retrospect about all those skills together, it will help you actually to have better interview processes. Today, the industry don't want only people who actually wants to code, but also how to move the business forward and create impact. And of course, this connects with the second skill that I mentioned here, which is decision making. Decision making helps you to focus on why I'm doing something, right? If you don't retrospect and if you don't know how to make a decision why I'm doing or why I'm facing a problem, you might just be busy all the time running tickets, going different direction. But actually, if you don't retrospect, if you don't know how to make a decision, you don't know which is the way that you are going. So if you focus on the why you are doing things, this is very important for a software engineer today, not only be in a comfort zone of basically be doing what it's being told to do, right? And it's going to help you to be outcome oriented. So basically, yes, I make a decision because I want to have impact. I don't want to make a decision because I want to play with technology A, B, and C. It's all about the impact that you generate on the decision making that you do. And of course, you're going to learn how to mitigate risks, which basically means your ability to define what are the pros and cons. And when you reflect on the why, when you learn how to make a decision, when you create your own framework to make a decision, you start mitigating the risks, right? Sometimes we just define what are the pros, we don't see the cons. And over time, when the cons affect us, we don't know what to do. And we go to a more reactive mode because we never discuss the cons, right? Sometimes it's very important when you're making decisions to actually mitigate the risks. Why this is important? Because it's going to give you business context. It means that basically it's not about, as I said, I implemented 10 tickets today, so I'm doing good, right? Sometimes it's better to implement one ticket and has a huge business impact that actually being the whole day busy and delivering something that maybe don't have a business impact, right? So your ability to actually make decisions will help you to focus on the most important things. And for that, by design, you're going to actually know how to have business context. You're going to understand the context where you are. It's going to enable yourself a more strategic mindset, which means you're also focused on the medium long term, not only in the short term of the things that you have to do. And we, of course, helps you to take context into account. What does it mean? It means that maybe you made a solution to solve a problem on a specific context, but maybe a few weeks later or years later, you face the same problem in a different context. Not necessarily the decision that you made before will actually apply to this one, right? So it's going to also help you in this ability to actually know your tools, identify the context, think where are the pros and cons, and actually make a decision. So yeah, where decision making will help you, right? On team interactions, when you talk to product managers, stakeholders, usually they are not very tech savvy oriented, or they are more business oriented. An engineer can help a lot the product owners and product managers, stakeholders to actually identify what is the impact of the technology that is behind. Right? It's going to help you on backlog prioritization. Maybe you have 10 things to do. What's going to be our most impactful thing? Sometimes we just prioritize based on what is easy or what is next or what we know, right? But in the end, it's about the business. It's about the impacts. This skill will also help you on how to prioritize the things that you have to do as a team. And of course, it's going to upskill some of your technical skills about architecture and code design. We cannot architect or design a codes without a context, without a business context behind. So it's very impossible to say this architecture is good or this code is good or not if you don't know what is your business context. In the end, it's going to upskill yourself also when making those decisions. Collaboration is the third hidden skill that I'd like to talk about. So what is the collaboration itself? Basically, software engineering is a social activity, right? Learning alone, just going to tutorials, it's going to speed up your technical skills. But in the end, social engineering, you are going to be part of a team. And this team needs to basically know how to work together. You cannot form teams of one person only unless you are a solo person, right? Which is fair. But in the end, if you want to go to a software engineer and go and work on the biggest companies or startups, you need to look into software engineer as a social activity, right? Which means collaboration is key. You cannot live in an isolator. You cannot only be the only person in a team that knows everything if you're not upskilling your team members and peers with yourself. And this also has to do with the ability to produce outcome working as a team. So imagine if I have a team where just half of the team is able to produce outcome, the other half is basically struggling. And I believe that you as an engineer, you need to have the ability to actually standardize the knowledge across the team. And this will also enable the other skill, which is communication, right? How are you going to communicate as a team? And basically, yeah, mid-levels, beginning of career, senior engineers, they should all work as a team and grow together over time. Why this is important? As I mentioned also, it's gonna, the knowledge sharing about the business, about what the team scope is, will actually be speeded up. You don't create bus factors, you actually move even the business faster. As we are also delivering value faster, right? So I just talk about that. When you work as a team, actually you're going to deliver value faster. Imagine if you have a team of 5 people and you have like 10 things on your backlog and you just give one thing for each one of the team members because you have that sense that let me parallelize so I can deliver values faster. In the end, you are not delivering faster, you are starting faster. In the end, the collaboration is missing because in the end, you need to go through different steps like code review, guarantee quality assurance, and get a faster feedback loop. So the more you work together, the more you collaborate together, the more value you're going to deliver. And of course, if you're working as a team and if you're collaborating, you're going to be finding bottlenecks over time sooner. And if you remove them, you're going to have a way to efficiently tackle them. Sometimes you might get, if you're not very collaborating in the team, your team is very individual, you're going to find your bottlenecks very late. And bottlenecks will always exist. You just need to find them as soon as possible and as a team face them, right? So that's one of the reasons why collaboration is key. Where this is basically applied, of course, any team setup, right? Mainly when you're dealing with complex topics that you don't know what success look like, or you need to do discovery to find where I'm gonna go. Sometimes it's also good, even when you are working individually. Sometimes this happens. Of course, you cannot just work as a team all the time, but sometimes escalation. When you are individual, you are working something, if you get stuck, you need to collaborate with someone, right? And getting a second opinion will help you on tests that are not progressing, right? And of course, it's going to enable pair and mobile programming, which is some things that the industry is moving a lot with extreme programming and other topics. If you are interested to go deeper, basically it's that social part where basically why we plan together, why we create roadmap together, why we do refinement together, but why not we code together, right? Usually we do everything as a team together, but when you go to code, we do alone. So that's something that the industry realized that the more time you work together, the more efficient we are. Last but not least, this is basically the last skill that I'd like to talk today, which is resilience. Resilience has to do with bias for action. It has to do with how I deal with circumstances that are not ideal. It has to do with you dealing with frustration. When you work in big companies or in small companies, it doesn't matter. It's never going to be perfect. And you can actually be a professional where you wait everything to be perfect so you can actually work. or you can be parts of the transformation that is required. So in that case, resilience helps you to actually have a bias for action. Let me do things instead of waiting for the things to be perfect. Will help you to overcome obstacles, and will help you to deal with frustration. Deal with frustration does not mean you cannot be frustrated. Dealing with frustration means how long time are you spending my frustration, and how are you actually pick my frustration to actually transform into actions to exactly solve the problem that I'm facing right now. And why resilience is important? As I said, perfect structure doesn't exist. So in your career, you're gonna most likely face non-perfect places. And if you are just waiting for the things to be perfect, actually you are not gonna grow, because things will not be perfect. It enables creativity. Why is that? Yes, I face a problem right now. So basically, I need to find a way, and sometimes you don't know how to find a way. And if you use collaboration, if you use retrospection, if you know how to make a decision, basically you can be creative and try to find something out of the box for you, right? And of course, also improves your communication, because in the end, you retrospect, you make a decision, and you actually collaborate. And for that, communication is really important. So resilience will enable also your communication. Where to apply? I believe that resilience, the most source of frustration that I see in the industry is where you're running projects that are cross team, where you need to deal with people that maybe you don't deal on a day-to-day basis. Basically, those cross-team projects where you're gonna wait for the orders and make assumptions. Things will not be perfect. So yeah, in those kind of projects, resilience is applied. Somehow, top-down decisions, you don't have any kind of influence on some decisions. They just come for you, and you have to obey them. In that moment, the frustration always can come. But yeah, it's time where you can actually take action and be creative and actually move forwards with that, right? So the resilience is quite important. And of course, in damage control situations, sometimes you're facing an incident, sometimes there is something that was not expected, and you can just give up, or you can actually try to damage the control by being resilient, by taking actions, by collaborating, by making a fast decision, and doing retrospection. That was the fourth hidden skill. So some final considerations, right? I think it was clear that everything is interconnected. Retrospection, the decision-making, resilience, collaboration, they are all a circle. You cannot have one without the other. And those four skills, they are non-exhaustive. There is so many other skills that surround those fours. Like communication and so on. And basically, at least in this, this helped me a lot on my career. And I wish that our industry would have awareness that those skills are very important. They are a foundation for your technical skills. The technical skills are still the most important ones, are the ones that will make the difference. But you should build those technical skills on top of a great foundation, right? And those four skills below, they helped me shape my career, and I believe that I'd like to contribute to the industry by raising awareness of them. That's basically it. Thank you very much for the time. You can reach me out in LinkedIn if you'd like to chat more about them, but happy also to answer questions right now if you have some.
If anyone has any questions, you can talk on the comments on the Q&A. And thank you so much, Leandro, for talking and giving this presentation. I think I learned a lot as well.
Sure, it was a pleasure for me. Thanks, Isa.
I think if there are any questions, it's going to pop up here. I guess no questions for now. Okay. Okay. There's a question. What is your favorite language to work with?
Tricky. Yeah, tricky question, right? Great question, Sofiane. The language that I most like to work with is the one that will solve the right problem to do, right? And it depends on the context, as I said. But I can tell you the language that I basically was built, my whole career was PHP, a backend language, right? And I know that PHP in the industry is not seen as a great language over time, a lot of hackies and so on. But in the end, it does the job. It does the job, right? I still would consider PHP for a lot of use cases, and I would never discard because of personal taste, right? I believe that the professionals in our area that just blame languages, they actually don't have those hidden skills that I just mentioned that basically are needed. In the end, it's not about the language, it's about your skills that you build, right? So PHP is a nice language. Of course, there are specific use cases where to use it. And yeah, I also like Node.js, Java, Python. I actually don't like so much Ruby, but it's not. It's a personal taste. I think Ruby does the job a lot. You have very successful companies with Ruby behind the scenes. And the ability of design your code is even more important than the language, because crappy codes or crappy design you can build in any language. And your ability to know how to design code, it's what really matters in the end. Cool. Thanks for the question.
I actually have another question as well, going off on this question. So you think, for example, to be hired, do you need to be good at one specific language? And then if you're like you said, you're good at coding this language and doing good code, do you think then you can be hired just knowing one language, or more than one would be better? I mean, it would be better, but
yeah, it's a great question. It really depends where you are applying. The industry is very diverse and big, and every company has a different maturity as well on their hiring process. So today we have companies, for example, where they actually want people to be like, let's say, Node.js. And usually they build the hiring process totally on the technical skills of Node.js. And sometimes you might hire someone who knows how to do Node.js, but they don't know how to collaborate. They don't know how to retrospect, how to make a decision, how to be resilient. In the end, they will not succeed. So the language will not actually be the one that will move you to the long term. There are companies who actually want to have software engineers. They usually put like 4 languages and say, if you are good enough in these 4 languages, you can actually be hired. In the end, you should focus more on how to strengthen your coding skills agnostic of the language. And the coding skills and understanding a little bit like solid patterns, clean code, clean architecture, those topics, they are agnostic of languages, and they are more important to know than the language. Because if you just go to the language, you cannot use the language properly using the things that are actually needed. And yeah, that's basically overall answering the questions. Yes, you can be hired if you know the language, but that's most likely is not going to be the only thing that make you move. The number of languages you know, right? The other topics actually, they will actually be the ones that will move the needle. And if you know one language very well, and you know all these clean architecture, clean codes, solid patterns, you're going to learn all the languages quite fast, I would say, because it doesn't change much on that sense. I think this question was already asked before about top skills.
I see another question here from Anita. She says, if you could introduce or recommend one new practice to the tech teams, what would it be?
Great questions. Great questions. I would like to answer this question in a different way. I would like to tell which is the process that I wouldn't take as granted. And what I mean by that, right? I believe our industry today is there is this trend and this hype on agility, what agile really means. And some people might just say that I'm doing Scrum, And I have stand-ups, I have retrospectives, I have sprint reviews, and I have burn down charts and so on. And when you do that, you don't focus so much on the value that you're delivering, you focus a lot on the process. And you actually have the feeling that the process is the goal, not the value that you're delivering. So one practice that I believe teams should do is exactly what I mentioned. Let's actually be more program. Let's work more together. Let's communicate more. And one practice that I log is extreme programming. If you read extreme programming, it talks about agility, it talks about collaboration, it talks about how to deliver value in small increments. And that ability is a skill as well. And I consider that a hard skill, not a soft skill. How can I actually deliver value in increments? How can I speed up my feedback loop? And this is what agility is. So I really recommend the book Accelerate, and every research on top of that. I believe this book was a game changer for our industry today. It talks about engineering productivity. In the end, it treats engineering as a pipeline of delivery, and you cannot achieve this pipeline of delivery without collaboration, without working small, without thinking about the value itself and the why behind. And usually, of course, Scrum is just a tool that will enable that, but it's not the end goal. And I believe our industry today, at least from interviews, I see a lot of people, yes, I do retrospective, I do stand-up, I do everything, but when you actually go deeper and ask what is the value of the stand-up, how do you know stand-up is not delivering value? People don't know how to answer this question, because usually they are focused on the process. So yeah, that's going to be my answer to this question.
Nice, thank you. And I think one more question, it's going to pop up there.
Yeah, great question as well. I believe the biggest advice that I give to you is don't focus on the technical things. Focus more on what is surrounded the language itself, as I mentioned, clean architecture, clean code, design, and of course on your communication skills that will enable basically retrospection, decision making, resilience, and collaboration. I think those aspects, the ability to give and receive feedback as well, it's something very important. And my advice, I believe we have a lot of content in our portal for Delivery Hero regarding how to prepare for the interview, what success looks like. And I believe we also have a lot of content about what is our culture, in terms of what we expect in terms of architectural guidelines, reliability, and it's public. And I believe the mindset that we are staying there is a mindset that also will help you to join Delivery Hero as a company, right? Because you have the content that is needed for you to upskill yourself to be part of the hiring process.
Okay, this is the last question, so.
I'm currently working as a fraud analyst. Yes, there is. I believe that's a very great question because in the end, security is one of the things that became trend in our industry today. I believe maybe 5-10 years ago, the security was a little bit side aspects on software engineering. Today, you see a lot of security positions open in different aspects. Data protection, privacy is a trend topic in our industry today. And I believe you, as a fraud analyst, you're going to work a lot with engineers who mainly work with payments and fintech, how to analyze basically payments that could be a fraud and so on. So there is parts of software engineering that treats security as a technology, as a skill, and you as a fraud analyst, you can just jump into security in software engineering in general and be specialized there. And there is a lot of open positions on this today. We build APIs, we build systems, all of them needs to have security aspects in place that needs to be implemented and developed, right? And I believe specialists on these are high demanded today in the market.
Yes. Thank you so much for answering, taking your time to talk to us in the presentation. It was very nice. So I'm going to jump into the next speakers. Our next session is going to be a little bit different. It's going to be a question and answer session with one of our software engineering bachelors and one of our data science bachelor students at ELU, Adrian Sardinat and Victor Radau. I'm not sure if I'm saying everyone's name right or not, but hi, Adrian. Hi, Victor. Thank you for joining me today. So just to start with, can you both tell me a little bit about yourself? Maybe Victor can start.
Hi, good afternoon. I'm Victor. I'm a second-year graduate at ELU, and I'm learning data science. I've chosen to come to this university as a mid-career move. Yeah.
Okay. Adrian.
Hello. Yes. I'm Adrian. I'm currently in Bali, live in Bali, and if I have to describe myself, I'd say I'm someone who I've just graduated from high school, but I'm someone who's extremely passionate about the future. I think the next 30 years will be a time of excitement and turbulence.
Nice. And so I'll start with you. Why did you decide to become a software engineer?
Me?
Yes.
Or-
You, Adrian.
The reason why I became a software engineer, well, there was two primary reasons. The first one being that I had a deep belief, at least in my circumstance, that software engineering is like a dual degree of management and software, because the engineering process itself is teaches you how to think much more effectively. And I think it could be said the same for other disciplines, but I think it's the most unique to engineers because we are the most concerned about efficiency and effectivity. And engineering also, one of the famous quotes that I like from Alfred P. Sloan is that he said similarly about his electrical engineering education being very valuable for when he became the CEO of General Motors. And I think it's doubly true for software engineering because working with computer programs all the time, we get the urge to constantly wanting to increase our thought process because as a software engineering, your productivity is directly proportional to how you sequence your thoughts and how value-adding those thoughts are. And so therefore, it urges you to do that. And in software engineering, you get a lot of chance to do that because computer programs are very malleable. You can change them quickly and get feedback from those things. And that's why I think that's a very core and an essential part of engineering. And another part, of course, is the knowledge and skills which you gain from it, which I don't think I need to explain because all the other people before me have said and explained why it is important and useful for the next 30 years or so.
Yeah, thank you. And what about you, Victor? I know you're studying data science, but why did you decide to study data science, become part of the tech industry?
Of course. So as I mentioned before, I've chosen to come to ELU for the purpose that I'm in a mid-career kind of case, and my current role and position is data analytics lead in my current role. And when I've been talking throughout the entire value chain of data analytics product, I've discovered that there is a certain gap in between the conversations I have with the business, where we are talking about business initiatives and business strategy, and the value the business wants to deliver, and its connection to the products data can provide you. And how do we create and shape our roadmaps, and how do we create and shape our end products, which are the consumables the business wants to use? How will they be connected? So all the time during these conversations, data science was considered like the magic box, the magic black box that I put some stuff into and some magic happens and I get some insights out of it. So I really wanted to break down and understand what's inside this magic box and how can I exploit that knowledge which comes with data science throughout my conversation with the business partners and implement it into the strategy of data analytics.
Very nice. And I know that you are working now, like you said, as a data analyst. How are you able like to combine your studies with your work?
Yeah, so the reason why, for instance, I've chosen this university because I didn't want to compromise my day-to-day work. And the program offers you the flexibility so you can, without compromising your activities during the day, you can still focus on learning during the evenings and during the weekends, and pretty much very flexibly, manage and organize your schedule of your specific program, of your specific cohort, to achieve the targets. I think also because the program is more practical, which I needed as a capability. I wanted to learn the skills comes with data science. I wanted to learn the methodologies of data science, and I wanted to get this knowledge the fastest I can through practical terms and practical programs.
Thank you. And Adrian, I believe you're not working, but I'm not sure. You just graduated high school. Are you working?
No, I'm fully studying, but like other students of ELU, I think I appreciate a lot the flexibility that it provides, because like them, I allocate some time to work with the ELU, but I also want to do a lot of other things on the offside on my own work.
Oh, okay. And so why did you both chose to study online rather than face to face? Why was that something good for you? Adrian, you can.
Okay. The reason why I chose online was because at the time, a semester ago, the pandemic situation was very uncertain. So therefore, I decided to do it online rather than do a university and then having to be locked down. And another part of it is, of course, that's on. So for software engineering, being online is not much of an obstacle because there's not an element of physical to it. Everything can be done online, and you get also a lot of freedom of action with being it online. You can do the things you think is better.
Yeah. And what about you, Victor?
I think it's the same reason. I mean, I think during the pandemic days, we could see that working online, managing teams online is working very well. And as I said before, I didn't want to have compromises on my work and day-to-day job, which can, be from early in the morning till late in the evenings. Going into specific locations could have jeopardized some of my flexible schedules across. So I didn't want to take this burden on of moving locations physically while I'm working with an entire kind of organization in a remote space anyway.
Yeah, I understand. I'm also doing my master's at ELU, so for me it's nice to be online, so it can be flexible for me to work as well. So if you guys could talk a little bit about your experience with the program so far, like what are some of the things that you've learned that you think are important? Victor.
I think one of the key takeaways from me was the practical part of it. You can with working with peers is teaching you a lot sidewise as well. But also you can learn how to find the ways around data science yourself, because partially you're given the program or the project. You have the online meetings where you meet your peers, meet your mentors, but there's a lot of background work. Do your own research, do your own case studies to understand a physical product at the end of the day, which you need to deliver to pass on to the next part of the specific season. So what I've learned out of it is like how you can come around a specific problem, and solutions are not given throughout the courses. You need to figure it out yourself. There's very seldom that we come to an end and we say, okay, this is how you solve it, but it's more like a different way of solving the same problem. It's more about, find your own ways, which I think will be very crucial in the later stages of anyone's work who is going to go to this path on a full-time job, actually.
Yeah, like Victor said before, it's important for you, like we try to teach you how to learn instead of just giving you all of the answers. And what about you, Adrian? I'm going to repeat the question, maybe you don't remember. Your program experience so far and some of the things that you've learned.
I think my program experience so far is very similar to Victor. As he said before, the experience with getting to understand the requirements of the project and having to do everything yourself, translating those into technical requirements, and then implementing those, verify, and all the things that are related to engineering is very valuable for me so far. It's the thing that I've said before in my previous answers, that I gradually begin to learn how to reflect on my previous activities and previous sessions and think about which part was value adding and which part were not value adding, and then to gradually think of a better way to do things. And I think it'll help a lot into the future, and I'll build into that. And also offside, in terms of my experience with ELU, that is not pertaining to the study but also related to it, is that it's not a heavily bureaucratic machine. It's ELU was very responsive to whenever I had a problem, and so I think very appreciative of that.
I'm glad. And also what you said before ties in with what Leandro said in his presentation about the soft skills as well. So it's nice to talk about that. So how do you think the studies will help you with your career, like your future? So for example, you, Victor, you want to change careers to another role.
Sorry. No, as I mentioned, this is kind of like my sort of chose to be. It's kind of a self-improvement skill set which I found myself throughout my career as a gap. I'm not seeing myself to be a full-time data scientist for the future. You never know. This capability is enabling you to be someone else and do a shift in your midlife career, as an example. I'm not planning to do that. What I'm planning is to, with this knowledge I'm learning in a university, gain more value and provide more value to our business stakeholders, as well as creating better products. And you were asking, using the skill set throughout my work. Actually, I did use it already, because we have had some use cases which were looking into pricing or promotion effectiveness, where we have used certain algorithms which were in fact which we have been looking into throughout one of the seasons of data science. And of course, it helped me to have a better straightforward conversation with my business partners, to understand that you have a problem, but obviously in a data transformation world, you can't expect literacy on a data level on the same space as a data scientist would be. So you need to have those bridges built which can help to translate those. And I can say that what I've learned from the school, I could use it for a better conversation and a better proposition for a product as an output, which I could hand over to the data science team to create a product at the end of the day.
Yeah, I think that's very nice also to understand what other people are doing in your team. It's very important if you want to have a good communication. And what about you, Adrian? Like, what do you want to do, like, with your future career? Do you have?
Yeah, I think for me, it's very similar to what Victor said, that the knowledge and the skills, I think, will not depreciate in the future. It's likely to come to use because it's just so core to everything. And if I imagine the next 30 years, I think it'll never depreciate. And in fact, might appreciate if I continue on this path. and I still have a long way to go, but I'm certain of it, that I'll make use of it. But also another benefit and value of this education is, again, I must emphasize the way of thinking of an engineer. I think it's very valuable, because you see that very visibly in Elon Musk and in Jeff Bezos and all the biographies that I've read. They think in a certain way and in a very clear way, and I just want to build that on my own, develop that as well, and because I think it's a good investment for whatever I will do. But of course I'm planning to pivot myself with technology.
That's nice. And for our last question, what advice would you give other people that are aspiring to become engineers or aspiring to study software engineer or data science, aspiring to be in where you are right now?
From what I see is that and being an engineer seems like a very competitive world, and so maybe it can sometimes feel so lonely at times. But the solution to that is probably my suggestion is to make life bigger than yourself, so that you feel that your life is more valuable, that you have a goal worth pursuing. And also, yeah, and sorry, I have to read my notes here. Oh, also, don't take engineering too seriously. I've seen some engineers who have in my search, engineers who've become too obsessed with being objective about things, and they do the same towards life and human emotions, and I don't think it's very ethical. I think if you become an engineer, you acquire the way of engineers, the way they think, but also retain the common empathy and values that basic human emotions have.
Yeah, that's a good it's a good tip. What about you, Victor?
It's a very interesting question, because I was wondering about there are two answers from my side on it, because obviously if you start your career, I think you need to have sort of a vision, where do you want to be, because computer science and data science are a constantly growing and evolving capabilities. It's not going to stop. If you go on this path, your knowledge today will be obsolete by tomorrow. So if you're on the path of a constant learning pace, understanding and going constantly after the market, the drivers, the key trends, then pretty much always have some sort of a vision where you want to end up. I think when I was considering myself as part of my mid-career, and I'm more going into the generalist space. I'm not, and that's why I'm saying I'm not looking myself necessarily a data scientist in the standard content. I think what is most important is to use the capabilities where it has to be and keep it there, because obviously these level of specialization in a generalist kind of layout could make you a bit biased, which you have to be careful, because then you can't focus really much on other topics than the skill set which you're learning. Because I mean, it's super exciting. There's always new challenges coming up. There's always new problems to solve, and normally whoever ends up here loves to solve problems. It's just the big picture should always be on the horizon, and the vision, who I want to be like 10 years from now.
Yeah, that's a good answer. I also have another question that I just thought of. It's since I know everything is online, the program is online. How do you feel connected to your peers, even though it's online? Maybe you can, whoever wants to answer.
Well, I haven't had much group projects. I've just had about 3, I think. But so far it's been helpful. I've communicated to them quite a lot, I think, for being given an online thing. I think it's relatively a lot.
Okay, good. What about you, Victor?
I think from my side, I can say that it's it's different. So you can't expect the same experience as you would go on a face-to-face university.
Mhm.
You will have people you're working together with. You will have people you're constantly working together with, and you will have potentially people who you see time to time, but not part of not part of your cohort, not part of your team. So the networking and the and kind of like the body structure, and obviously people are living all around the world, so I think it's really good for a professional perspective, and it's helping me a lot to work together with peers and run projects, because obviously some peers are much more experienced who will teach me something, some peers are less experienced who I can teach something. I think describing what you have understood from the specific topic is as crucial, because then you can explain how you understand the problem. So I think these are given, but if someone likes to have friends and build friendships and whatsoever, then probably the online space is not the best for that specifically.
Yeah, I agree about the when you're teaching someone something that you've learned, I think you learn it again and it gets more like ingrained in your head. I think that's very nice. So that was the last question. I don't know if anyone in the audience has any questions for me or for them. I don't see any question right now. So, okay, that's it. Thank you so much, both of you, for coming and talking to me, replying to some of my questions, and having a little chat.
Thank
you
you.
too.
Thank you. Bye.
Bye.
So, okay, so for our next speaker, his name is Christian Gill from Scarf. He has been to our summit before, and we loved having him, so we want to call him again. He's a senior software engineer at Scarf, which is a very interesting company, and he will give us a great talk today on how's a day on the life of a software engineer, so you guys can understand a little bit more about the day today. So welcome. And you're on mute as well.
Of course, that's how online meetings go, right?
Exactly.
Can you hear me well?
Yes, yes. Great.
Nice. I have some slides. Yeah, perfect. Well, so the day in the life of a software engineer, I think there is like a lot to talk about it. You have probably seen like these videos online where they go through the day and show you how they make their coffee in the morning and join meetings and so on. I won't do that, but I'll tell you like a few key aspects. I recently joined Piñata, so I'm working at Piñata now. Sorry, Isadora, I didn't update that, but I work there. Piñata is a company that does task management for real world work, so management of like on-site marketing projects and such. And I do the front end and the back end, a little bit of both. So some will say that this is like full stack. And as how does my day look like? Well, in my case, I work remotely. I work fully remotely. My closest colleague lives 2 countries away. in Poland, I live in the Netherlands, so it's fully remote. But if you were going to the office, that will look a bit differently. And it also depends if the company you work at is more focused on the social aspects of work, or it's only there for work and that's it. When I used to go to the office in my previous like on-site job, there were a lot of activities after work, like social activities, like going to arts museums, or maybe playing sports or something like that. So it depends also on the type of company and the culture of the company. But the work itself of a software engineer is about solving problems. And you will work together with different people in different domains to solve those problems. You will have designers working for you, or other software engineers that work maybe someone that does like the mobile application, someone that does the backend, someone that works on the front end. So you will communicate and work together with these people, and these problems might be like product and business related, where you are trying to improve the experience of the product for your users. Or there might be technical problems, like trying to maybe optimize how your application is deployed, so it or the test of your application runs, so they go faster and you can see the feedback of your work much faster, or trying to integrate a new library or a new framework into your tech stack. So the problems are different, but that's basically your work. As I mentioned, I work remotely. So in my case, and my team is mostly in the US, besides this colleague here in Europe. So my mornings are usually solo. I work alone in the morning. I do more of a deep work, focusing on trying to solve the problem at hand. Maybe I will pair with my colleague, or continue alone on my own. One thing I really like about working in tech in general, not only as a software engineer, is the fact that it's really flexible. And as I mentioned, with these different types of companies, you are able to choose the culture of where you want to work for. Maybe you want to do like 9 to 5 work and that's it, or maybe you want to work later in the evenings and you can find a company that it's really dynamic and lets you work in the hours that you would like to work, or maybe you want to do stuff in the weekend and have one day in the week free. That you can find different things like that. In my case, one of the things I like of this flexibility is the option to relocate. So I'm from Argentina. I was working there for around 4 years or 3 years. Did my first few jobs in Argentina, and then with my wife we decided to relocate to Europe, and I got an offer and we moved here. And thanks to the work, that was possible in a very straightforward way, without going through a lot of hoops in immigration and so on. And now I work remotely. After living in a big city for a few years, we got tired and we moved to a small town. I found a remote job that I can do it from home. And I'm close to the nature, so I can, like 15 minutes away, this is where I took this picture. I can walk with the dog in the fields and then go back to continue working. So I really like this flexibility. For you, you might want to maybe live close to the center and be close to the museums, or be ready to do a lot of social activities, or you want to live in a city that, I don't know, is close to the beach and you want to enjoy a nice weather. I think these are really nice opportunities that you can have by either working remotely or finding a job in a place where you want to move. Another key aspects of software is, as I mentioned, is working with the team. Also, collaboration and communication is key. Here, you will work with teammates that are doing the same thing as you, and you will try to solve the problems together. Maybe you will have sessions where you plan how to solve a certain problem, and then you will implement it yourself, or a colleague of yours will implement it, or you will have paid programming sessions and tackle a technical problem together. You will also have sessions collaborating with designers. Let's say you work in the front-end side of the application, and you will have also feedback about the experience of the user and what can be done and what cannot be done. Maybe the designers come with some crazy idea to make some really flashy design, and you will tell them this will take a lot of work or something like that, but there will be a lot of collaboration. These will, as I mentioned, look different depending on the company. Some companies will have a lot of meetings and do synchronous work and solve these problems together on the spot, and some other companies prefer a more asynchronous style where everybody collaborates, maybe on Notion or in Google Docs, and you put your comments, your thoughts, and maybe you sleep overnight and think about it and come up with maybe another suggestion or better idea. So it really depends on like the type of team. Usually, if you work on site or maybe you work a few days in the office, you will have more meetings that are focused on like leveraging the fact that you are face to face with your peers. At the moment, I don't have a lot of meetings at my work in Piñata. So that's something I personally like. I'm not a fan of having a lot of meetings. I do like to have like one-on-one pair programming sessions, like ad hoc when you need. But in general, you will find that some companies have a lot of meetings in, well, I don't know if you like it or not, but there are these formalities that's part of the job. And things like writing reports or performance reviews that you will do, or maybe helping in interviews to new colleagues, that new potential colleagues. So those are different things that you will do as well. At the moment, I recently joined Piñata, as I mentioned, so I have a lot of pair programming sessions with my colleagues to learn about the new the systems and the domain and the product. And this is something that usually happens like in the first 1 or 2 months when you join a new team or a new company and you have to get up to speed with the project. Besides that, I personally really like to write code, and I do it as a hobby as well. And something that it's important to keep in mind is that you have to keep learning. Like technology is changing all the time. The tech stack that like the technology and the projects, the frameworks they taught me in college were very different to the one I use today. So you have to continue learning, and yeah, technology goes fast. So if you like to do small side projects or conference or go to meetups, I really recommend you do it, because it will help you to stay up to date with the trends in the industry and what the industry is looking for. An example, when I started doing front end, like around 7 years ago, nobody was talking about TypeScript, and today it's maybe like a big requirement if you want to work on the front end side. So yeah, you have to stay up to date, and if you like it, it can also be fun to do side projects and activities like that. An example of something that my previous company used to do every December, there is this Advent of Code event where it's like an advent calendar where you solve problems every day, and we were competing to each other doing it after work hours, and it was a nice activity, and it helped us to stay sharp on like algorithms and solving problems. So that's more or less, I think I went very fast, but that's more or less like different aspects of the day. As a recap, working in tech and as a software engineer specifically brings you amazing opportunities, be it to work on a project or a company that you really like and you really resonate with the product and what they're doing and what they're trying to solve or how they're trying to help the clients. Or maybe it means that you can work remotely and travel. There are all sorts of opportunities that you will find. The work itself is about solving problems. So if you like to do that, you will have fun in working as a software engineer. It's really exciting when you are in this process of, stuck on a solution, but then you find it and you feel good about it. Although it's about solving problems, I think people are as important as writing the code, and maybe more important, the communication that you have with your colleagues and the collaboration will really make the work more interesting. And because of that, communication is really important. As I said, with the opportunities, it's flexible, so you can make it work for you. You can find the type of work that you like to do, and that adapts to your expectations. There's also boring stuff, maybe meetings or reports or things that you personally don't like, but that's with every job. So no matter what you do, there will be always boring stuff, and you will always have to keep learning. And yeah, remember that. I think it's also a really interesting part of the job, at least personally for me. If I was doing the same thing and using the same technology for like 10 years, I think I will really get bored. I couldn't do it. So I like to keep like finding new things to do and new tools that are added to the tech stack to solve problems. And I think that is also really cool. And I think, yeah, that's it. I don't know if there are questions. Otherwise, you can find me on Twitter if you have like a specific question.
I was on mute as well. I have a question here that says,
Yes.
"Hi, I'm a project lead and planning to be a technical manager. So, what would you suggest me to do?"
As if you want to be a technical manager, it depends how technically you want to get involved. If you want to collaborate on the more like software and architectural decisions, you want to go pretty deep into that aspect. If you want to do it more from the product side, I think it's still good to learn, to have an idea of what the engineers in the team are doing, to be able to understand their work, and to be able to help them in their needs. So
Okay.
learning either a little bit or very deep, depending on the needs, it's going to be required.
Okay. Thank you so much for coming again and talking to us. It was great having you. I'm sure everyone will benefit a lot.
Thank you for the invitation.
Thank you. So I'm going to present our next speaker. His name is Christopher Evans. He's the Technology Sector Director at Rulian. He'll be giving us some tips and tricks on how to become a software engineer and lots of different data on software engineering career. So welcome, Chris.
Hello.
Hi.
Nice to see you. How you doing?
Good. How are you?
Yeah, good, thank you.
Oh,
So I'm going to share a little bit of data around the current state of the market. So my background is I've spent 20 years now largely supporting European businesses, from startup to scale up and then up to enterprise level. And quite frankly, there's probably never been a better time to move into the tech industry. So I'll dive straight in. If you have questions, put them in the chat box, and I'll try and answer as many as I can as we work through this. I'm a little bit of a tech novice myself, so if my slides don't tend to work, if someone just pops a message in, that'll be brilliant. So let's start with where we are. So the tech economy is currently massively under-resourced across Europe. So the EU state that we require in the region of around 20 million specialists within digital skills by the year 2030. And we currently only have 9 million. So there is effectively 11 million people that we need to train, upskill, and create experts within just to fulfill the baseline need of what's required over the next 7 years, which is huge. Only around 54% of Europeans aged between 16 and 74 have at least basic digital skills. So that's even down to not necessarily coding per se. This is just fundamental how to use technology platforms. And overall, it costs the economy, depending on which report you look at, anywhere between 50 and 75 billion euros. You can see from the chart on the right that on average, over 50% of European countries and the organizations within those countries struggle to attract digital talent. So there is a huge demand for skills and a huge demand for workers within this space. Female representation is growing, but it's still nowhere near the levels that it should be. The UK leads Europe and actually the globe entirely at around 31% female representation. The US is second at around 28%. And whilst we've seen significant growth, so compared to 10 years ago, there's now 68% more women within tech, that only actually turns the dial by around 2% over the last 10 years. Germany, France, Spain, the Netherlands, Italy are all increasing female representation, but there's still a huge gulf and a significant amount of work that needs to be done. Now, if you look at current education outputs, around 54% of students in STEM subjects are female, but for whatever reason, we're not making that bridge between academia and employment. And that's something in vacancies that effectively we're going to have over the next 7 years. So programs such as career transitions, return to work cohorts, cross-training, academies and so forth are all really trying to push to drastically increase the number of tech skills and disciplines we have available within the European economy. So one of the big reasons why most people consider a digital career is, well, there's a number of benefits I'll come on to, but the main one is reward. So salaries by country are typically higher by around 40% than the total country average. Average software engineering salary across the whole of Europe is currently just over 53,000. Sorry, currently below 53,000 euros. But it's not uncommon to see senior and lead engineers, upwards of 80 to 120,000 euros on average. Certainly, we've seen significant growth in recent years. There's a lot of media talk about big company layoffs, and there's certainly a trend of the larger US businesses. But coming back to this huge gulf and hole of talent that we have, the demand continues to outstrip the supply, and as a result, it tends to be a market that is led by the individual. So entry-level salaries may be slightly less than this. These are the market norms, but at the same time, we see the average usually coming in at 2 to 3 years worth of experience. By tech, so one of the benefits of a career in tech is that you're constantly learning. One of the challenges is that you're constantly afraid of your skills being outdated. So if we rewind this graph to probably 10 years ago, it would look completely different. Even 3 years ago, it would look very different. So Golang and Rust have grown significantly in the last 3 years. Rust itself has tripled in demand since 2020. As you can see, there's a circa 3 years ago, there was 600,000 Rust developers globally. It's currently 2.2 million, and that number is growing rapidly. There's currently in the region of around expected 3.5 million Rust developers required globally at the moment, which again just shows that the demand completely outstrips the supply. So not only is it a case of choosing to be a software engineer, but also which technologies you choose to focus on will directly impact your earning potential as well. Similarly, we've seen huge growth in Java, huge growth in Ruby, Python due to its application with data engineering, certainly around ML and AI platforms, and also Golang, which has seen considerable growth. Well, it's expected to see considerable growth, around 25% over the next 3 years. So what are the benefits? So we take a survey of around 5,000 individuals every year and ask them what the perks of being a software engineer are. And the key 6 themes that came out of our most recent are these on screen. So due to the demand growing, it means that there's more opportunities available. People have greater choices. They're not restricted to location, they're not restricted to skill set, industry, company. And as a result, more opportunity gives them the chance to move into new sectors, new career paths, new locations, and so forth. Software engineering typically scores in the top 3 of job satisfaction surveys globally, partly for reasons such as flexibility, autonomy, but generally speaking, we tend to find that those in digital careers are largely happier than those not, and certainly those in software engineering are some of the happiest people within the tech community. Touched upon flexibility. Since 2020, we've seen a number of organizations move to remote working, but more interestingly, we've seen a trend where 96% of the software engineers that we have deployed into organizations have all benefited from some form of remote working. Around 40% of those are fully remote, and around 30% of those have a work from anywhere policy. So they're complete digital nomads. Continuous learning, as we touched upon. I've never met a single software engineer, and I'm sure the other presenters that are from technical disciplines will echo this sentiment, that there's never an opportunity to continue to learn and grow. It does support creativity. Maybe software engineering isn't seen in the same light as digital marketing, but for those that are taking a concept or an idea and turning that into a user-friendly application that can be used by millions of people, it certainly does lean on people to be creative. And the long-term prospects, I think we've certainly seen a trend of software engineers moving into senior and lead roles. We definitely see the trend of former engineers moving into CTO and CIO positions. Founders of startups and scale-ups tend to come from an engineering background. If we look at kind of mainstream media, I don't think a day goes by where Elon Musk doesn't appear somewhere on my news feeds. He himself was once upon a time an engineer. So if you're looking for a career that not only offers you immediate benefit, but can offer you longer term prospects as well, then it's a really easy decision to make, I think. And then the desirable skills outside of engineering. So yes, understanding how to code, understanding the technical side is really important, but we tend to find that most organizations and employers are looking for a number of softer skills as well. So when making applications, I think there's a couple of tips that we could offer. Firstly is to make sure that you're listing these desirable skills as a standard within your profile, cover letter, LinkedIn, CV, and so forth. That you're clear in terms of how you communicate, that you can give examples as to how you've built relationships, maybe how you've managed stakeholders, how you've engaged with customers. For problem solving, we recommend referencing some examples as to case studies as to where you've overcome a challenge or an obstacle. We would recommend using the STAR method, which looks at the situation. So what was there when you were presented with the problem? The task, so how you broke that down into a series of objectives or actions. The action that you undertook and how that worked or did not. What the result was and how that benefited either the organization, the stakeholder, the company. And the final part is the lessons learned. So the ability to demonstrate that you can reflect on that and recognize what went right, what went wrong, and how you can improve. Teamwork. Certainly, engineering is not a role of isolation. You'll be part of a team, you'll be part of tribes, you'll be part of squads. And as a result, collaboration is absolutely key. So whether or not you can demonstrate that through your profiles and CVs as paired exercises, whether or not you can demonstrate how you build relationships and work with others across different time zones, different cultures. Remote working, certainly, as we touched upon for digital nomads, means that they may work in isolation. That doesn't mean that you're not part of a team. Productivity. One of the key things that we tend to look for is individuals that not only can write great code, but are productive in the way they do so. So what are the structures, the frameworks, the tools that you use to drive productivity? What are the efficiencies that you've created by doing things in certain ways? How much time or effort has been saved through the actions that you took? And finally, creativity. Employers look for individuals that can not only just code, but can also actually think creatively and innovatively. So what new concepts have you brought? What new tools have you recommended? What new ways of working could you introduce? Effectively, what employers are looking for is not only people that have great technical capability, but who can bring thought leadership, who can bring collaboration with their existing teams, their suppliers, their customers, and fundamentally who can solve problems. And then onto remote interviews. As you can see, around 80% of our customers include remote interviewing as part of standard of their process. And just a couple of top tips that people maybe miss as a result of that. Firstly, silence your notifications. There's so many times that people are interviewed, and I've foolishly not done it myself today. So you might be able to hear my Teams pinging away in the background, and it's a distraction naturally to anyone. Dress professionally. We've all heard scare stories. I've seen them firsthand of where someone's on a video interview, they stand up to answer the door, they're in their board shorts whilst wearing a shirt. Treat an interview, whether or not it's remote or not, as you would do in person. Keep your background simple. Use a digital one if you can. Try to remove clutter and distraction. What you don't want is, if you're in a busy environment, if you're in a coffee shop, you're in a library and you're undertaking an interview, you've got noise and people moving around in the background will take the focus off you and what you're saying. Check your lighting. Certainly make sure that the contrast is okay, you're not backlit, and so forth, so the interviewer can see you clearly. Move your mobile with kind of similar to notifications. You don't want distractions. You definitely don't want your mobile going off in front of you. And certainly it's a real faux pas to be looking at it whilst you're in discussion. And test your technology. Similarly today, I've checked 3 times that I knew I was able to use the platform and that I could load my presentation. Similarly, we'd recommend for doing so for any form of video interview. Certainly if you're used to using Zoom and you get a Google Hangout, or you're used to using Teams and you're using a different platform, it's worthwhile just becoming a fay with how each one operates. And that's all from me. So hopefully that gives you an indicator as to where in the world is currently hiring, where some of the regions with the highest demand are, where the highest average salaries are, and which technologies you might want to consider if things like earning potential are one of the driver. Also, in summary, why and some of the benefits of becoming a software engineer and why it's important, and how it could benefit you both in the short and near term as well as for longer career prospects. And if anyone would like any more advice, guidance on interviewing, preparation, how to secure a role, then please visit rulian.co.uk for more information.
Hi, hello. So I actually have a question for you, but I'm also going to wait for other questions if there are. When you say video interviews, do you mean interview with someone or like recorded interviews? Because I know there are many different kinds.
Yeah, sure. So I think the advice is that I presented is mainly for an interactive interview. But the same rules would apply to if a video recording as well. I think there's a huge increase of pre-recorded interviews and the application of those.
Mhm.
But we would suggest treating it as you would a formal interview.
Okay.
It's first impressions count, and human behavior, as much as we'd all like to assume has completely evolved, hasn't quite. So as much as I've seen examples where somebody responds to a pre-recorded interview and they're walking the dog, and whilst it's quite cute that they're walking the dog, does it give the best first impression? Maybe not in the eyes of all hirers.
I think my internet is working now. Yes.
Yeah, you could.
I think I got cut off a little bit. Like you were saying, of technology, maybe mine wasn't the best. But also another question that I have, when software engineers are applying for jobs, are they asked to do like case studies?
Less likely. More likely is there'll be some form of online assessment. So
Okay.
there's a number of different platforms that companies use now that provide, whether or not those are traditional tests, so kind of multiple choice, whether or not they're exercises where they ask someone to write sample code, or whether they are paired with an employee of the organization to observe how someone would handle a problem in a real world situation. So there's a lot. If those watching would like more information on that, if you simply look at online technology assessments, if you pop that into Google, there's tons of different providers, and most of them offer the opportunity to try one and for yourself.
Okay, perfect. Thank you. I think we don't have any other questions for now. So thank you so much, Chris, for coming and talking and showing all of the data. I think it was very insightful. I think everyone wants to see it again, but thank you. And so I'm going to introduce our next speaker. Her name is Opal Russell. I'm not sure I'm saying it right. Opal is a content creator. She's a freelance writer, and she's going to talk about what is software engineering and the future of software development. So, hello, welcome.
Hi,
How are you?
welcome. Thank you so much for the wonderful introduction, Isadora. That was great.
Of course.
I'm just so pleased to be here today. Sorry, technical glitch there. Yeah, no, it's wonderful. Like you were mentioning, I'm a writer. I'm very enthusiastic researcher. And it's an honor to be here with you today. I'm going to be speaking about surprising global opinions surrounding artificial intelligence and different countries and how they're approaching this rapidly evolving technology. So before we dive into like the actual opinions that we're going to get to, let's just take a moment to reflect on some of these cool artificial intelligence. Actually, they're pretty much fascinating facts that not everyone would know. So the first one I'll start with is in 1956, the Dartmouth conference was considered, I didn't pull up my presentation, so I'm going to do that right now so you can see it. My apologies. Share screen. Sorry, technical difficulty there. My screen completely went black, so I can't see you. My apologies. I'm so sorry for that. I'm having some issues just getting the presentation to come up. No, I had it, but there we go. I don't know what the issue is there, but I did try to get the...
If you click on present.
Yep. And then so I have a Google Slides as well. So I go Google Slides, and then add Google Slides, and then add my presentation. And for some reason, I don't know why. There we go. I got it. Perfect. There we go. So back to where I was. Now the tricky part is getting it to process. Okay, there we go. So we're going to be talking today. We're going to be talking today a little bit about, as I mentioned, some surprising facts. So just to get going, I'm so sorry for that interruption there, but artificial intelligence is viewed differently, and there's different approaches to it. It's a rapidly evolving technology, and some cool facts, like I was saying, is in 1956, the Dartmouth, I believe it's a university, was the birthplace of AI. So that's kind of where I left off. And then I'll jump into some other facts. I'm sorry. That was the birthplace. It's actually Dartmouth Conference, come to think of it. And AI is already being used in things like healthcare to help diagnose diseases and treatment plans and improve patient outcomes. And the financial industry has also adopted AI, which helps detect and prevent fraud and makes economic predictions. So that's pretty cool. And integrating AI in self-driving cars aims to improve road safety and reduce the number of accidents caused by humans or human error. Very fascinating. But AI is also used in agriculture to increase crop yields, reduce waste, and conserve water. In some countries, actually, AI is utilized to monitor things like air and water quality and to prevent environmental disasters, which is kind of cool. The education sector also benefits from AI. So with this type of technology, it really can personalize your learning experience and provides personalized feedback to the students. So that's good. And AI has the potential to reduce poverty and inequality by automating jobs that are dangerous, repetitive, or low paying. So that's a given. It's very immersive technology. AI can address global challenges such as climate change, food security, and healthcare by providing new insights and solutions. And lastly, with my fun facts, I'll just say the law enforcement and legal industries have utilized this AI technology to analyze data and identify patterns that can lead to the prevention of crimes, which is just fascinating. So we're going to jump on over here to India. Oopsies. India takes a very different approach. India is a rapidly developing country and has been increasingly adopting AI intelligence or artificial intelligence, AI, in various sectors. One of the unique ways that India uses this technology actually is in social issues such as poverty, healthcare, education. And India has a large population, and AI is being used to help provide access to resources actually and services for people in remote or underprivileged areas. So it's really good. And they also use the healthcare sector, and AI is being used to develop affordable, accessible diagnostic tools. Things like the Indian Institution of Technology, IIT in Delhi, they developed an AI-powered tool that can diagnose diabetes retinopathy. I hope I pronounced that correctly, a leading cause of blindness in India. And this tool can be used in remote areas as well, where there's not necessarily specialized doctors or limited access to doctors. In the education sector in India, AI is being used to provide personalized and interactive learning experiences for students in general. So companies like BYJU have developed AI-based learning platforms that provide adaptive learning experiences for students independently. And in their agriculture sector, AI is being used to help increase crop yields and efficiency. So companies like AgroStar have developed AI-powered mobile apps that provide real-time advice for farmers on crop management, soil equality, and weather forecasting. So in India, it's also very unique because their approach to data privacy and security is very broad. The Indian government has implemented strict regulations to protect the privacy of its citizens' data, and companies operating in India must comply with these regulations. It's just a must. So we're going to switch over here to Germany. Around the world, Germany has a distinct perception because AI is shaped by its historical and economical strengths and its cultural values. Germany is known for its engineering and manufacturing expertise, and AI is a critical enabler to the industrial competitiveness of the country. So the German government has been actively promoting AI through various initiatives and investments to establish the country as a hub of AI innovation and applications. So one exciting piece about Germany is its approach to AI and its focus on industrial AI, which aims to increase efficiency, productivity, competitiveness in key areas such as manufacturing and logistics and energy. So this is really reflected in Germany's development of advanced AI systems for Industrial 4.0 and the Internet of Things, the LOT, which are transforming the ways that businesses operate, essentially. And another aspect I would say of Germany's outlook is AI is recognized, or its recognition of the potential ethical and social implications of AI, and its efforts to address these concerns are of the highmost concern to them. For example, they've established the Ethics Commission of Automated Connected Driving, which brings together experts from industries, academia, and civil society to talk about the ethical use of autonomous vehicles and develop guidelines and for responsible use and development. So Germany's view of AI is characteristic to the combination of like a technical and ethical awareness and a commitment to using AI in enhanced industrial competitiveness. So that might be a great place for you to get to. Now we're going to jump across the world to China. With its rapidly evolving concept of AI, it's shaped by sheer scale, remarkable in all extent the economical growth and its ambitious visions for the future, AI is a critical driver in innovation and social progress. And the Chinese government has been promoting these various initiatives and investments to become a world leader in AI innovation. Like, that is their goal. It's very, very intense. One intriguing aspect of China's approach to AI is focusing on practical applications, which aims to harness the power of AI to solve real-world problems and improve people's lives. And you can see this directly reflected in China's rapid development of AI systems in fields such as healthcare, finance, transport, and all of these in which are transforming the way the businesses and individuals operate or run in a country concept. So another aspect of China's perception is its focus on data-driven AI, which leverages China's vast and growing data ecosystem and builds and trains AI models at scale. So this has enabled China to make rapid progress in fields such as natural language processing and computer vision, and is helping to establish the country as a leader in AI research and development. China also, I would define it as kind of a combination of technical innovation and ambition, and a commitment to using AI to drive economical growth and advancements in scientific knowledge. So if we just go straight to the guts, let's go to the United States here. There's some fun facts I can tell you, but we'll get to that at the end here. The United States actually has a very dynamic view on AI, shaped by its history of innovation and entrepreneurship spirit, and cultural diversity too. AI is seen as a critical driver of economic growth. And one fascinating aspect, like truly, is its approach on focusing on cutting edge research and development, which aims to push the boundaries of what is possible with AI. And this is reflected through US's world-class universities, research institutions, and startup ecosystems, which are at the forefront of AI innovation and discovery. So the USA has established the National Security Commission of AI, which brings together experts from industry, again, academia, and the government to discuss AI and developing guidelines for responsible use and development and utilization. So that's super important. The US, I would define that as a combination of possibly technical ambition and like entrepreneurship. So we see a lot of that. Now, just going to get to Japan. We're going to go back into Asia. Japan has such a unique perspective because it's kind of shaped from its history and culture. And Japan has been on the forefront of technical innovation for many years, and AI is seen as a way to drive economical prospects. And one aspect of that is AI is focusing on human-centered AI, which aims to enhance human capabilities and improve people's lives rather than simply replacing them. So they put a lot of effort and energy into things like their healthcare and development of advanced robotics and AI systems for healthcare, aging populations, and disability supports. So they have a different view altogether. Another aspect of that would be it's able to recognize the potential issues with it and its efforts to address these concerns. So Japan really knows that there are threats associated with AI. And for an example, they've established the Council of Promotion of Responsible AI and as a regulatory body to assist with governing the immersive technology, but still nonetheless, they're very aware that it is potentially dangerous. And to them, I think it's characterized as more of a combination of technical optimism and like ethical vigilance, and a commitment to using AI in ways that benefit both the individuals and society as a whole. So now we're just going to talk a little bit about education and awareness. This is my favorite part. Before we conclude anything, we must look into the risks and dangers associated with AI and the critical role of individuals entering into the software engineering and AI industries. AI can cause significant harm if it's developed and used irresponsibly, so it must be used responsibly. And one primary concern with this potential of AI and its ability to perpetuate or amplify existing biases and discrimination in society. For example, this is really bizarre. Facial recognition systems have been proven less accurate for people with darker skin tones, resulting in false arrests and other harmful consequences. That's just devastating. So to address this, it's essential to use diverse and representative data sets to regularly regularly evaluate and address any biases in your AI systems. We can also ensure that the benefits of AI are shared by all rather than just a select few, and that its impact on our society is a positive one and sustainable. So, I guess another aspect of this is research and development, and its significant risk to AI to displace jobs and exacerbate economic inequality. AI has the potential to automate many jobs that are dangerous, repetitive, and low paying. However, it could also lead to widespread job losses, particularly in industries such as manufacturing and retail, putting many people out of work. To mitigate these risks, it's critical to ensure that workers retained and equipped and trained with the right skills necessary for jobs for the future, and that the benefits of AI are distributed equitably. So now this is my most important thing. If you're going to remember one thing about me, remember my name is Opal, and remember to start a conversation in your community. It's clear that the opinions and approaches towards AI vary significantly, but are similar in some aspects across the globe. So one thing is sure, that the conversations around AI need to continue in our communities. People need to be informed and educated about the potential benefits and risks of AI, and so that AI can be made more informed and decisions about AI can impact our lives. So we really want to run this by the right people and take some ethics with you into this career. And we can start these conversations in our local communities by organizing things like workshops, panel discussions, and other events to bring experts in the field of AI and members of the general public together to discuss it. And this will allow people to learn more about AI, ask questions, and share their thoughts and concerns. And by fostering these conversations amongst yourselves and in your communities, we can work together with principles of ethics, like I was saying, and transparency and accountability to guide the development of and use of AI. So just to conclude here, in conclusion, I would say individuals entering the software engineering and AI industries, it is critical to have a deep understanding of ethical implications of AI and to develop AI systems that are transparent, accountable, and free of bias. And this can be achieved through rigorous education and training in ethics, human rights, and social justice, as well as ongoing collaboration with various stakeholders, including experts or policymakers in these areas. And AI has the potential to bring significant benefits to society, and we must be aware of its potential risks and take steps to mitigate them. So by being responsible and ethical in the development and use of AI, we can ensure that its impact on society, again, is equitable and sustainable. That's so important. But just some fun facts. I have some cool technologies I would love to list off to you. I may not pronounce them all correctly because I haven't dove into all these, but there's like TensorFlow. I'm sure maybe some of you have heard about that. It's an open source platform for building and deploying machine learning models created by Google. I personally haven't used it, but there's Keras, is a high level neural networks API written in Python and capable of running on top of TensorFlow, CNTK, and Theno. So that's just another kind of AI you can use. Or there's PyTorch, which is a machine learning library that provides easy to use APIs for building and training deep learning models created by Facebook. And OpenAI Gym, which is a great tool, has a toolkit for developing and comparing reinforcing learning algorithms, including a collection of environments to test and benchmark different algorithms. So Hugging Face actually is a good one, a library for pre-trained models for natural language processing, including sentiment analytics and language translation. So IBM Watson Studio, a cloud-based platform for building, training, and developing machine learning models developed by IBM. That's a great one to use. And SkitKit, is a library of like tools for processing model selection and evaluation. So just, you'll have to explore these on your own, but we're getting to some of my favorite ones. NVIDIA, so NVIDIA, Deep Learning Institute, is a place online where you can get training and you can really get the courses and resources for beginners or experts. and CAFFE, CAFFE, a deep learning framework developed by Berkeley in AI research, optimizes image classification and segmentation. But my favorite of all is Chatbot, so ChatGTP, and its questions provide information and generate text based on the user's input. So that's really fascinating. And does anyone have any questions? Thank you so much for letting me speak.
Hi. I think the questions take a little while to come in,
No,
but
it's no problem.
I just wanted to say I also really like Chat GPT, and I was actually talking to someone about that, and he's like, "Oh, it's not fun anymore because you can put anything in there and they can do it for you."
Well,
Now,
I think to add to that, though, you have to learn to speak computer. So using these AI systems, you can't just say like, write me a code. It will do exactly what you tell it to do. But if you don't have the right approach, one great tip is use the word hypothetical. So if you're trying to talk to an AI, say hypothetically, what would you do in this situation? Or whatever your question is, how would you write a resume? Using different language than we would normally use actually really amplifies the technology. And people find it almost useless, like, oh, we can just make whatever. But can we? Because if we don't make it correctly, or it only knows what we know. So
yeah,
we really have to be careful how we train it.
exactly. I think right now there are no other questions, but
That's
if
cool.
there are any other questions, I'll let you know after. And you
For
can
sure.
also email her. Everything is in our website.
Yeah. Well, thank you so much for having me. This has
Thank
been
you so much
wonderful.
for coming and telling us about AI.
Yeah.
Okay, and then for the next speaker, which is last but not least, is Ilke. I don't know how to pronounce the last name, but I'm going to try. Tosunoglu. He is an ethics hacker and a developer at the Future Partners. So a little bit of a different session than our other speakers. He's going to give a little presentation on himself, and then it's going to be questions and answers with the audience, so you can ask him anything and he can inspire you to become a software engineer.
Hello.
So,
Thanks for having me. And I'm excited to be part of the TechMind Summit. I've prepared a small presentation to introduce myself. Let me quickly present it. Yes. It's processing. Yes, I think it is there. Yes, thank you. Yet again, thank you for having me. I'm Ilke, a freelance ethical hacker. I have worked in many different companies. Here are a few of them, and especially right now I'm a part of the Future Partners. It's a collective of all freelance IT guys, just like me, doing a lot of different parts of IT. You can think of security, software engineering, definitely a lot of those guys, DevOps, management, all kinds of stuff. People that are more interested, you can scan the QR code to my LinkedIn profile and connect with me. A little bit about me. I have 9 years of work experience in IT general, and 8 years of that I dedicated to IT security. Back in the time, I started as a system engineer, worked as a network engineer, I got into software engineering. That was a part of my ethical hacker training. I loved it that much that I'm still developing software in my free time. Since last year, April 1st, I started freelancing. The sectors that I've worked for during my ethical hacker time, I had the pleasure to make a lot of different organizations a little bit safer. You can think about government agencies, financial institutions, healthcare, manufacturing plants, and other businesses like enterprises as well as smaller businesses. And that's it about me. Time for questions. I see there is a question from Annika. My advice for weak programmers in doing coding interviews. Well, I'm more of a IT security guy, but when you say weak programmers, I think there are no weak programmers. They're just people that are learning. If during those interviews, if you have feedback, definitely listen to the feedback and try to learn from them and improve. What programming languages go into ethical hacking? Yeah, that's well, most of people that think about Python right away because it's a high-level language, easy to learn, and it can be quite fun. And there is a really big community that has already developed a lot of libraries that you can use to achieve your goals. But eventually, software is written in many different languages. And when you are presented with a security question, a penetration test, as we call it in the industry, you need to adapt. You need to learn that language. Most of the time, when you have seen a few languages, you will see that it follows the basic principles of for loops, if else's, and while loops, and just the basic structures of programming. If you know those, you can read almost any language and get things done. Next question. Wilson, I'm currently working as a fraud analyst in Berlin. I would like to know what is the main area to focus on most as a software engineer. Well, for fraud analyst, you're basically looking at certain transactions, and transactions are either benign or they are fraudulent. And you need to look at the first stages. Most of the time, you can get it flagged, and from there on, you need to investigate, because legally you're not allowed to do fraud analyzing automatically. There always needs to be a human involved. How someone with 40-year-old that have just started software engineering will be able to have the first job? I don't think age has anything to do with getting your first job. You need to just get out there, show yourself, have a bit of faith. Most of the time you are enthusiastic in what you do, and when you show that, people will definitely hire you. Just in the previous presentations, when they talked about soft skills, those are really important. Work on those. the technical skills will come. The hacking stages, yes, that's a very good question. There are many different types of hacking stages. A lot of organizations try to standardize it, but the most important one is that one of MITRE attack framework. Let me just let me put a nice thing up. Yes. Basically, it has a few stages, and it always starts with the reconnaissance. You're just looking around, seeing how it works, what is out there, trying some benign stuff like the way how you normally would use the application. And during those reconnaissance stages, you always put your developer hat on by thinking about, if I was the developer of this application, how would I have done it? And what kind of things I would be able to do wrong here? And then you start in the next stage, that you start to poke around and learn a bit more about how the application behaves. Key thing here is that user input is really bad, and it can escalate quickly. So by trying stuff out, I can see like, oh, this is how the developer has built it. So if I do this and this and this, then I can do some malicious stuff. And that's the execution stage. You execute your payload, your malicious user input, and then the application reacts in a unspecified way that the program maybe not even intended, but yet it does. And from there on, you get access to maybe the web server or the underlying infrastructure. And from there on, you start to have a privilege escalation stage. That's where you have some influence, but you're not fully in control of the machine yet. So you escalate your privileges. That's a whole another art. And then during those privilege escalation, you always need to look out for defensive measures that have been put through. So defense evasion is also an important part there you need to think about. And once that you have achieved the highest privileges, you trying to, as we say, root the machine. So you take control, you upload your malware, and you establish command and control of that server. And from there on, you do the same things again, rinse and repeat, and try to do lateral movement to other parts of the network, to other machines, maybe other users that are using the application, and try to compromise everything you get till you find something interesting that you want to show your clients. Say like, hey, I've managed to penetrate this deeply, and I found some sensitive information. Maybe there's some trade secrets, or even worse, personal information from people from clients, from regular people. Here in the EU, there are major fines if you do not fix them properly. And from there on, when you get that information, you can always try to exfiltrate it. So that's the stage where you try to get the data from their infrastructure to your infrastructure. And finally, that kind of concludes. Next question. Yes. IT security is very wide, just as wide as any other IT area, because, hackers don't care about if you're a developer or a system engineer or a network engineer or just some regular user. So first you need to think about what kind of IT security area do you want to track to? I personally started with web application pen testing because it's fairly easy to start with. And from there on, I went into infrastructure pen testing. And from there on, I got into red teaming. Red teaming is like a catch-all test that the company can conduct, where you do not target specific infrastructure, but you target the entire organization, from the people to the applications they use, till the email, till their websites. Everything is almostly permitted. So if you want to develop into IT security areas, I suggest you to try to discover, see what's out there, and try to find something that you're really interested in and have fun with. And my main suggestion for that is look for capture the flag sites. Those think about Hack in the Box or RootMe, and there are many others. A really good website to note down is WeChal.net. That's a website that has a list of all the capture the flag sites where you can just legally try your skills out as an ethical hacker. Even if you do not know anything, most of those websites will help you out in a certain way to develop those skills. Next question, please. Yes, that's a fun question to answer. The thing is, I was always interested in IT security. I can remember from when I was like 10 years old. I like to play video games, and the classical thing, parents did not like it. They tried to lock down the PC with a password or something else, and I always found an intuitive way to access the computer again to play my games. And from there on, my parents said, like, when I was a little bit older, like, yeah, you should do IT, because as your parents, we know that you will succeed in that way. And during my school time, I also experimented with security by developing a little bit, building infrastructure, and also doing a bit ethical hacking on capture the flag sites. And from there on, I already knew, like, I wanted to do this because I wanted to do this. And that's the most important part. You need to have fun. Having fun is the most important part for your career path. So as a software engineer, you have a very, very good base to start with IT security. So I would say try to expand on that. Next question, please. Yes. That's thank you, Brandon. Brandon is a good friend of mine, and it is an excellent question that he's asking me. Yet again, capture the flag websites are also for experienced practitioners. There are special kind of challenges there that simulate whole networks, even enterprise networks, with also defensive measures in place, where you can test your skills to the fullest. Those environments are usually just as real as if you were doing an actual penetration test at the client. So try them out. In some websites like Hack in the Box, you even get a certification from them if you complete the challenges. And that's also a nice addition to your CV. What are the top technical and people skills for a software engineer? Well, yet in the previous presentations from our other presenters, they said soft skills are really important. You need to work in a team, and you're never able to cover all the parts of a software engineering team. So the parts that you're less good at, other people are usually a little bit better at, and from there on, you can work together. Working together is key, because together you will get better, and together you will learn better. So from that, collaborating with each other is really important. And as top technical, I would say always learn a little bit Linux and Unix commands. Those are always useful. You never know when they are needed. Next question. You seem to have a good career transition in tech. What are your career tips for those who are looking into for transition in tech domain? I would say if you're interested, try things out yourself. Find the areas that really pique your interest. Once your interest is piqued, you will eventually find your path, and eventually your career transition into tech. Yet again, having fun is the most important part. Next question. How do you stay up to date with the latest technologies and techniques in ethical hacking? That's a really good question. I have built up a newsfeed in the past several years by just reading, trying out different news websites, and also a few other sources like Twitter and Reddit. Those places are really good to stay up to date with the latest technologies. I would recommend the NetSec subreddit, and also on Twitter to follow a few key figures in the industry. Maybe a good one is Sportswigger. Those guys are phenomenal with the newest technologies on web pen testing and ethical hacking. And there are many others. Just research and see what's out there, and once you find something interesting, start following them, and you might have some good insights from those people. Standard tools. Usually, I'm more of a guy that wants to build its own tools because it gives me a much more flexibility in the type of stuff I'm doing. But there are a bunch of really, really great tools out there for specific tasks. Maybe you want to note down, maybe if you want to do web pen testing, you should look at Burp Suite. That's like a Swiss Army knife for the job. It can do almost anything you want. If you want to do infrastructure testing, Nmap port scanner, that's one of the best port scanners you can start with to discover and start the reconnaissance phase. And not only tools, but also offline resources, or we say passive reconnaissance, we call them. Things like Shodan or Census are really, really great websites that collect a lot of information that you can use during a penetration test. For example, Shodan is like the Google for IP addresses on the internet. You can find a lot of stuff there. Maybe on Census, they keep track of all the certificates that are being given out for websites. There you can also see a lot of interesting stuff and discover a lot of infrastructure of clients. Another tool, yeah, I think definitely learning a programming language is also one of the most powerful tools that you can have in your repertoire. My go-to is usually Python, but I'm not shy to use other languages as well, like Golang or C or C++. So those are, I think, the best tools. Next question.
Hi, I think we asked most of the questions. Most of the questions were asked. So thank you so much for answering all of the questions. I know there were a lot of different questions, and I'm glad you're here to answer them. So just as we're finishing our summit, I just wanted to also talk about what we heard and what we learned during other speakers. I heard a lot about the different languages like that people should or shouldn't learn, and something that resonated with me a lot was that the languages, you don't need to be very specific in one language. You need to learn the coding skills, and then if you know that, you're going to be able to code with whatever language, and you're going to be able to learn fast.
Definitely.
So that's something that really, I thought it was nice, because sometimes I'm like, oh, I only know one language, maybe I should, but and another thing that I found that was very interesting were the soft skills, that a lot of people talked about, the soft skills that are needed for software engineers. And I feel that that is not very talked about usually. Lots of people, or at least people that are applying or starting their career, they think more about the hard skills than the soft skills. And the soft skills are a very important part as well, not just when you are already in the job that you're working with the team, but also in the interview part. You're going to have to talk to someone, you're going to have to communicate and explain what you're doing. And so I thought that was very nice.
Indeed, Isadora, that is really important, the soft skills. Eventually, we're building software, but people are using it. So soft skills are almost the most important part.
Okay. So thank you so much for coming, for doing your Q&A and talking a little bit with us. So it was very inspiring and informative as well. So to finish, I want to thank you, everyone who came, participated, shared their insights. I know I learned a lot. I think all of the speakers also learned a lot from the other speakers. It was very, very informative. This is the end of our virtual summit. I had a great time. I hope everyone enjoyed as well, and learned as much as I did from every single speaker. I think everyone talked about different things, but you could tell that they all tie in together at the end. So I think it was very informative. But I'd like to thank the speakers for coming, taking the time of their day and talking to everyone. But I also want to thank tech support and marketing support, Ibrahim. You can't see him, but he's backstage doing everything. So thank you. Also, ELU's founder, Alper, who helped us organize the event, and everyone who came and watched and asked questions. And if you want to know more about the organizers, give us a follow. Or if you want to know anything about any of the speakers, you can also email us and we can give you more information. So thank you, everyone. Bye.